What's up, Travis?
Hey, you guys got no audio on YouTube.
Oh, sweet. Holy shit, man. I was killing the
You heard
introduction.
Brandon?
Yeah. I'm so sorry, guys. So I just wanted to keep you in suspense, but thanks to Travis who popped in and bonked me on the head and said I had no audio. So what's up? You guys will be catching up to me in about 20 seconds here, but let me start that over, and I do apologize for that. I'm going to say...
I haven't even been talking. He left to go do the intro or whatever.
Yep. Yep. Audio wasn't on, so got that covered. Now let's say hello to everybody. Squirrel Sniper, what's up? We've got FES, GPS. We'll look into that Doppler shift one of these days. Gleam, SE Montreal. What's up, man? The Plain Truth, Travis. Thanks for saving my ass there. Sorry about the dead air again, guys. Rachie, Quintuple Zero. I still have to figure that out. I got to look out what 5 of something
Travis,
is.
I just want to say before
Ian Adams,
I talk about what I'm about to talk about,
Rantoy.
I have all the respect
I don't know
for
if I like that
all
or
the
not.
pictures you take and everything.
And
So
we
just so
did
you know
have a
that.
new channel member tonight. Hello to everybody else out
Alright.
there if I missed you. Heted 1949 says,
I'm
cheers,
not trying
Ranty,
to take
stay
away
safe.
anything from what you've
And
done
he
or what you're
joined
going to
as
do.
a shrimp member. So
Yeah,
thanks,
no worries,
Heted
man. It's,
1949. Really appreciate that. You too can become a channel member. There is a link underneath the information. Or if you want to support the show another way, you can, there is a Patreon link. You can super chat. But the biggest thing you can do to support the show is to help us figure out the shape of the earth, provide content, come in and talk. And that would be the best. Okay. Let's see who we have in the Discord.
there's
All
so many
right.
different ways.
Hey guys, we're live now. And thanks, Travis, again for saving my ass. I had to do the intro twice. I think it was better the first time, but the second time wasn't too bad. So I do appreciate that. We've got... what's that?
Sorry. Nah, it was a joke. Go ahead.
Oh, okay. We've got Jeremy. What's going on, Jeremy?
Not much, not much.
Cool. We got Jimbo. Are you there, Jimbo? No? All right. We'll catch back up with Jimbo. Okay, well, why don't we start off the show talking about a couple things that happened over the last 24 hours. I know that Jeremy and Jimbo wanted some time to talk about a possible experiment they're going to conduct with the fishing line.
That was Brian.
Oh, Brian. Why do I keep thinking that's Jimbo? Yeah, that was Brian. Hopefully he'll join later. For some reason, I thought it was him. But yeah, Jeremy, if you want to talk about it anyway without Brian here, or if you need Brian here, we can wait.
No, I'd love to. I got 5 minutes and I got to cook the kids dinner real quick.
Okay, go shoot, man.
So if I could just jump right into it. All right. No optical thing is going to end this. I think we've all come to the realization of this. You know, no picture, laser beams, nothing optical is going to end this. Light bends. So we're screwed if we try to do any optical thing. What we need is something tangible that you could touch. You know, that doesn't have no light bending. There's no refraction at play or anything. So the premise of the idea is, you know, you get a probably about a mile or two. You're going to need probably 2 miles. There's only, I think, a 16-inch Sagita bulge in 2 miles. So I think that's enough wiggle room. So you get 2 miles worth of some buoyant line, some very high pound test buoyant line. I'm not a line expert. We might need to
monofilament, brother.
Oh, we got Brian that joined. Hey, Brian.
Yeah, so you need to get 2 miles of this line, right? It's buoyant, so there's not going to be any sag. It's going to be sagging up because it's going to want to float. You know, you've eliminated the sag by pulling this line tight underwater. You know, you go a foot, 2 feet underwater, 6 inches, whatever. I don't know the exact numbers, but you get it underwater, and then you pull it tight. You have a scale on one side, so you can make sure you don't break the line. And you just pull it tight over 2 miles, and you bring a tape measure to the middle. And you know, there's either going to be a bulge or there's not. Now, if it measures flat, it's over with. The water's not curving. It's done. We can all move on, knowing that the water's not curving. You know, you might want to do this measurement a few more times, but if it does measure as a globe, then it could be the buoyancy of the line that's messing this up. So all this test does is it falsifies the globe. It'll falsify water curving at 8 inches per mile, essentially, you know? So that's all. Go ahead.
All right. Yeah. So that makes sense to me. So what are the possible results? Can you just list them right now and what you think each of the results would mean? And then, Brian, I'll let you jump in. I just want to ask that one question real quick to clarify.
I mean, the line is going to go be, if say you start with each end of the line 1 foot underwater, then the middle of the line should be close to a foot. It might be off an inch or two from the buoyancy of the line or whatever. But another possibility, you know, if that happens and it's only off an inch or two and there's not the, you know, if we do it 2 miles and there's not the 16 inches of curvature there, then it's case closed, it's over with. You know, you can go out and do the measurement a few more times in other places around the world and that'd be great. But the other option is it's going to measure curved, and then we'll have to rethink our strategy because it could be from the buoyancy of the line. So, you know, we just have to do it and see what happens. I feel like.
So you're going to start with the line 1 foot underwater at each end. You're going to pull it tight. And if it moves down, that would indicate that there is still a possibility of curvature. If it doesn't tend down, then that would indicate that there is no curvature. Is that right?
No, you bring a tape measure to the middle of it. You go to where the middle of the line is, 1 mile out.
Yep.
You get your tape measure and you measure the how far the line is from the top of the water. So if you go out and you measure it and we have a foot on each side and it measures a foot in the middle, boom, it's flat. You know, we can all move on. If it's an inch or two off, they need to go ahead, Brian.
Yeah, that's fine. I like it. I mean, I agree with everything you're saying. I just think that, the monofilament is neutrally buoyant. See, I had separate spools of like almost a mile, like 30 yard. I was gonna tether together, but I found they have 5,280 yard spools, which is exactly 3 miles. I was trying to go a little over 3 miles because the line is neutrally buoyant. It's monofilament. So when they're trying to tell you to use this fiber line or spider wire, any of this shit, okay, maybe that is a little stronger, it can support itself, but not in water. In water, the fact that it's neutrally buoyant, so it'll tend to float, but as you pull it under, then it'll follow suit. And there's a couple things. I've thought about it, and I think underwater would be better, but I think just a little bit underwater, not much, if any, but yeah, maybe let's say, in my idea, I'm thinking like about 6 inches or something like that. And so if we sink the middle down just a little bit, so if all the line is 6 inches from the top of the water, and it's curving, okay, so when we pull it down just a foot or so in the middle, or a couple feet, whatever, then and I'm going to give it a minute to catch up. You pull the tension out and just give it a minute as you pull it tight, pull it slowly, and let it catch up. Because no matter if the earth is flat or spherical, if you pull that line down, initially it might gesture up a little bit, but as the tension catches up, and in my opinion, if we let the tension catch up and we pull it tight and we have the middle down at about, let's just say for this discussion, 1 foot, if it goes down further than that, then to me the water is curving. I mean, I don't know how else to put it. I can cross that threshold when I get there, but in my mind, I'm not really trying to come up with. I'm trying to. That's why I like discussing this, because everybody's got new stuff to add in and whatnot. But if it gestures upward, once the tension catches up and it gestures upward, it doesn't have to come all the way up to the top. If it gestures upward, that water is one of three things: either not curving like they say, flat, or concave. Take your pick. It's not what they tell us. Either way,
it has to go down a certain minimum amount, right? That's the point. In order for it to be globe, if it doesn't go down that minimum amount, then it's not. That falsifies the curvature.
Yeah, I think I might have mixed up what I said at the beginning. There should be a ball. It should be deeper.
Deeper if it's a globe.
In the middle, yeah.
Okay.
But I would suggest using buoyant, not neutral buoyant. I would do just buoyant line. That way the Globers couldn't say anything. They would have nothing to say about sag. We want line that floats. You know what I mean? There'll be no complaints after. Well, maybe it wasn't totally neutral buoyant and it was sinking a little bit. No, it's buoyant. It floats. Case closed. You know.
I think it's wishful thinking to think it's going to be that easy and a one-time boom, it's over. And I just don't think it's realistic. But I'd play a wait and see. There are obstacles that you'll face. There's surface tension to the water. You want to submerge a line 3 miles of it through the surface tension of the water. Well, that's going to take some tension. We'll see what happens. But even if you get your results where, quote, it's under the water, you think it's going to tell me that the water's curving? What's wrong with you people?
Yeah, no, I agree with you there.
There's
But
something wrong in your noodles.
Jimbo, no one thinks that you're going to do this one test and that's going to be game over. But for a lot of people, if you can falsify that there's curvature, if you can show with some kind of physical measurement that the amount of curvature that you're measuring doesn't conform to the ball model, that is a pretty powerful proof.
Yeah, I've already done it a few hundred yards just to see how much the line was sagging. And there's a little video of it. It's hard to see the line, but I've sunk it under the water and pulled it right up out of the water. I mean, it pulled up out of the water effortlessly, the line I had. And now I'm going to scale up to it's almost a mile. And I got a spot. I'm just going to float it on top. And this neutrally buoyant line does tend to float, Jeremy. It says neutrally buoyant. But in my opinion, if we use buoyant line, then they're going to have more complaints. But that's just my opinion. I'm willing to hear what you think about what you said. One other thing, it's only I'm not sure if the 12. I had 3 sets of lines out. I had over 600 yards. I had 12 pound, 80 pound, and 30 pound, and I never did measure to see which one. I never did take enough time to individually see which one held its weight the best. But I don't think that's going to be a big factor in the water. I think as far as in the water with neutrally buoyant or slightly buoyant line, sag is it's just not going to be a factor. You can get that line tight, damn near completely tight, if not all the way tight. All we need is a little bit of like Brandon said, it's just got to gesture up or down to tell us the results. I think our common sense all tells us it'll gesture upward, man, and the water's flat.
Yeah, obviously this measurement would need to be done a bunch more times, but once we got one in the flat earthers know, look, this is how we show them, and then maybe more people would start doing it. And I think I did mess up in the beginning. In order for there to be a globe, they're going to want it deeper in the middle. So I think line that sags actually benefits the globe. No,
it would tend to the error would be in favor of the globe, meaning you're never going to get it at exactly 1 foot if that's your starting line on
that's
both
true
ends.
That's a good point.
We want to use
the curved. It wouldn't sag. It would sort of like arc over the curve at 3 miles.
Right.
Okay.
And so I think it'll work over this mile, man. But if it works over the mile, then I think it'll work pretty much indefinitely. We'll see.
I think it'll work over a mile. I think going much past that might be a lot more difficult.
We want to use the line that favors the globe. That way there's no complaints from the globe after we measure it flat. You know what I mean? So whatever line, I think you're going to want sag, line that sags, because that would help it make it deeper in the middle, and they couldn't say.
I think we're getting some feedback from you.
In other words, if it's
Hey guys, we're getting
wait, Jeremy.
Well, hold on, guys, hold on. We're getting really bad feedback from someone's mic, so if you're not talking, just try to go on mute, please. Go ahead, Brian.
One other thing, and I got to go temporarily, guys. If we get buoyant line and it's floating, they'll say that's why it pulled up, is because the line's trying to float upwards. You see what I'm saying?
Yeah, we're gonna want line that sags. You're right.
Yeah, because that's the problem, right? Yeah, you want it to be the error to be on the side of the globe. I didn't think of that because you're going to have problem pulling it tight. So yeah, they'll say it floats up. So you have to design it in a way the error can only be on the globe side.
That's right. We're going to want line that sags. No neutral buoyant or buoyant. I had it mixed up and backwards at first. I apologize. but we want to use the line that's in favor of the globe. That way, when we measure it flat, no one can come back complaining or saying, "Oh, the line float."
Why don't you use both? Is it that much more
This is
expensive?
I mean, it's expensive line. Yeah, you got to get hundreds of pound test line. It's not cheap.
It's not that much. It's $100, man. It's $100 for 3 miles, man, and from 3 to 5 miles.
That's it.
So
Oh,
why
that's
not
it.
do both? The floaty kind and the whatever saggy kind.
Yeah. We only,
That is
but I
my
mean,
First,
opinion, because
before
you
anybody
compare
buys
them
any
both to
line,
each other.
Before anybody buys any line, I'll tell you what, no matter what, I'll do this tonight. I should have already did this. I will tell you which work. It kind of seemed like the 12 pound. I mean, it seems light and fragile, but trust me when I tell you it's not. I will try tonight. I'll try the 12, the 30, and the 80. I had the 50, but I will try all three, and I'll try and report back before this show's over which one supports its weight the best, because it's not as cut and dry as you think. So I'll try and have that done by the end of the show. Over and out, guys.
All right,
I was
we'll see you in a while,
later,
Brian.
I was thinking of using like that deep sea fishing line that's like 500-pound test or something. Like I said, I'm not a line expert, but I know they pull up some pretty big like tunas and stuff out of the ocean.
Codfish
So
line.
How are
I
you?
mean, hold on, Brandon. If we're looking for line that sags, I mean, they make, I don't know if paracord floats or sinks, but paracord, they make 1,100-pound test paracord. So that should be pretty good right there. 1,100 pounds. I feel like you'd get a guitar string tightness out of that.
Yeah, that is pretty good. I was looking at carbon fiber line myself when I was thinking about this, and it's pretty expensive, but it's pretty strong, and they use it to lay out long factories because it's more accurate than lasers. So they actually use it to lay out machinery where the precision has to be just dead nuts.
Yeah, whatever line we use, though, we should at first use the line. I agree with Jimbo about using both lines, but I mean, before you start buying tons of lines, let's just buy the one that errs to the side of the globe, favors the globe. That way it'll be cut and dry after that.
That's fair.
Yeah, I would say that somebody needs to do a short write-up, doesn't have to be anything elaborate, that describes the test procedures and the expected outcomes before we do it so that we can all, take a look at it and just get some agreement. I think that's going to be in the benefit of whoever actually goes out and does it. That would be my recommendation. So, I know Brian's thinking about doing it. Jeremy, you're sounds like you're on the verge of putting it together yourself and going out and doing it.
I mean, if I had 2 miles worth of land, I'd be out there digging a trench right now to fill up with water, put the line over.
I know that's the problem is finding a good place with water that, because it can't be running at all. So it has to be some kind of trench or something where still water sits in it constantly.
Canals. They have canals that don't flow. And, I mean, yeah, I don't know. The water's tough. I mean, let's get the line sorted out, what kind of line we want to use. And then you can just start bringing it around to different bodies of water if you needed to,
Yeah. Okay.
Yeah, as long as you make sure you don't snap the line, you need a scale, one of those like fish scales or something, so that you make sure, if you have a 500-pound test line, you got the scale there, so you make sure you're not putting more than 500 pounds on it, because you don't want to snap your line, so you can reuse it over and over again for different bodies of water or whatever.
Yeah. How are you going to winch it down on the ends? Just physically, like pull on it, or use a fishing, what are those called? Where you reel it in, fishing reel?
I envision this being done on the edge of the water. Like I'm not saying you go to like the middle of a lake or something. Like I feel like this needs to be done on the edge of the water, so you can drive like a post into the ground on one side, tie it off there, and put your scale on it or whatever there, and then 2 miles down the way, you dig another post into the ground with like a O screw on it or something, so you could loop the string through and then winch it out through that. You know what I mean?
Yeah. Okay.
Like picture being on a beach. You go in just deep enough to where it's 6 inches deep or a foot deep or whatever. You drive your little like stakes or posts in or whatever that you're going to tie this thing off to. Then 2 miles on a road, you do the same thing. So that way it's underneath, but you could have the winch up top pulling it through. You know what I mean?
Yeah. All right. So more to come on that, I guess. I see that we've got Aaron that joined. What's up, Aaron? You just listening in, or are you able to talk now?
I'm just listening in right now. Gotta go pick up a machine.
A machine. Okay. What kind of machine?
Skid steer.
Okay.
Well, yeah.
I don't know why I wanted to know, but cool.
You know, just doing dirt work, making the earth flat.
Gotcha. So that's actually your job then, Aaron, is to help make the earth flat.
Help keep it flat. Yeah.
Keep it flat. Okay. That's pretty good.
Yeah.
All right. I do have a couple of things. Oh, go ahead. Sorry.
I could dig Jeremy's trench for him too whenever he's ready.
Yeah, that's going to be quite some work to dig a trench that long.
I did a 1/4 mile in about 6 hours, 2 feet deep.
Huh. Well, okay. Maybe that's not such a crazy idea then, digging the own trench.
Hell yeah, it'd just take a couple days.
Gotcha. Okay.
Right on.
All right. Now, I do have something. Oh, before I get into that, I want to talk to you guys about the after show yesterday. Unfortunately, I didn't record it, but it was absolutely insane. So from now on, I will be recording the after show, especially if we have a big group in, because it was crazy. A lot of fun, really funny. There was like 5 people showing their screen and just insanity, pure insanity. So if you're not in the Discord and you're interested in, just hanging out and talking about Flat Earth or whatever after the shows or when there's not a show, the Discord link is in the description. So feel free to join. I know a lot of the regulars are already members there. You can come in. We are infested with globe trolls, unfortunately, but that's kind of a fact of living on Earth. So yeah. Okay, here's what I wanted to share. Hopefully this is big enough. So back to perspective real quick. Nothing too in-depth tonight, but there is a discussion that continues about, is sight the same as Euclidean geometry? And if you'll remember last night, myself and Gleam discussed and shared some experimental evidence, some peer-reviewed papers that basically said, bottom line is, perspective is not the same as Euclidean geometry. The way we see the world cannot be translated one for one to a Euclidean into Euclidean geometry. If you were to draw something as you see it, especially from distance, and then say build it from that, it would not look how it should. It's pretty obvious to most people, but where the argument takes place is when we talk about stuff like the altitude to Polaris and how far down on the horizon things should look when they go a certain distance. But mostly this has been coming up because of Polaris. And I want to point out this comment on the screen, and B-Ball's in chat, so maybe he can come in and kind of explain what he's talking about. But the top of it, he says, stop avoiding citation and documents that destroy your flat earth and only picking the ones you like. That's called cherry picking. Well, first of all, that's not cherry picking. So if there is something in a paper that supports, experimental evidence that supports my position, or that I think is evidence of what I think is reality, and there are things in other papers that I don't agree with, and I don't use the ones I don't agree with, and I do use the ones I do agree with, that's not cherry picking. If it was, then I would have to agree with everything that's been written in a peer-reviewed paper from here back to the start of when peer-review papers were created. B-Ball posts these papers that, eventually say, or essentially say, the earth is flat. What they really do is presuppose, or that's not the earth is flat, that the earth's a ball. They pretty much just presuppose that the earth's a ball and then come up with some kind of correlation to support their position. But he thinks that because I cite these papers from these PhDs on optics and perspective, that I should have to agree with every single thing that a scientist has written in a peer-reviewed paper, including that the Earth's a globe. Now, obviously, that is a ludicrous position. But I did keep asking him another question. So that's one. I did keep asking him another question, which was, when using your sight with a tool such as a sextant to measure things in the world, when you look out and you measure things with a sextant or just based on your perspective, would it match Euclidean geometry? And you can see on screen what B-Ball's position is that yes, when using our sight along with the tools to measure things in the world, it'll match Euclidean geometry. Until you try to measure the surface of a sphere. So evidently perspective fails to match Euclidean geometry if you're measuring things on a sphere. So I don't know where the fuck he thinks we're talking about, but according to him, we live on a sphere, which would mean that any time we try to use our perspective to measure things or draw a Euclidean diagram and claim that it matches the real world or how we see things, that under his position here, it would be invalid because his position is also that we live on a globe. So that's a nice little piece of cognitive dissonance and talking out of both sides of your mouth that I thought you guys would enjoy. So this kind of gets more toward the little trick that they're doing in this conflation of Euclidean geometry and perspective. So anybody got any thoughts on that? See, we're joined by Right the Hand. What's up, man? And let's see who's in here. Chad joined. Brian Leakey's back. What's going on? All right, so that's that. Another thing I wanted to show you guys was just thinking more about perspective. And I had this great shot down the street. There's these clouds that are at pretty low, and they fill the sky. And they go down to the horizon. And you can see that it slants pretty severely. This is about what it looked like visually with my eyes. So my question was, are these clouds going down to the horizon because the Earth is curved? Because they don't look like they go very far. And they look like they slant down pretty damn quickly. Or is this the way we see things? Does anybody know the answer? Or have an opinion on that? It's a pretty simple question, yeah. I know, but
I don't think they're going down because the Earth's a curve. That's my opinion.
Yeah. So obviously these go to a finite vanishing point in the distance. These are up pretty high. I don't know what the cloud ceiling is. Maybe that's like 500, 1,000 feet. It's really hard to tell. But obviously these are not going down to the horizon because we're looking out and the Earth is curving away from us. It's too short a distance. The math wouldn't work out. There is a finite vanishing point for perspective that makes it look like everything vanishes into the ground much closer than would happen on a ball. Not only that, it's linear, so it's a straight line, not a curve. All right, so that was about it there. Anybody got anything on that before I go somewhere else?
The Earth's not big enough to, or it's not small enough to curve on like that local to do that. To me, it's not. They say in everything you can observe, it's basically a flat plane. It's like 0.01. So it can't be Earth curve, even if the Earth is a.
Yeah, right. So obviously, you know, these are not really slanting down. I don't know, maybe what is that? It's really tough to judge distance because that's a part of the perspective distortion, but it's got to be like 10 miles away, maybe that you see this final cloud here above the trees? So, you know, the clouds are not sloping down within 10 miles because of earth curve. That is not what's happening in reality. This is obviously distorted. So how would I model this using Euclidean geometry? If I was looking at this and measuring the angles literally and the distances, how would I model this? What would it look like if I tried to draw a diagram basing my Euclidean geometry and the lines that I drew based on what I see here?
Just like an art student would do it. All straight lines that go to the center.
Yeah, it would just look like a slant down to the center, like a triangle of vision, right? So that's the point I've been trying to hit home these last few days, and get some people to understand. I don't know why I'm trying to get the trolls in Discord to understand perspective, because they cannot give up on this point. They cannot make this admission that sight is perspective based and not, we don't see in Euclidean geometry, because it really fucks up their whole model. Then they have nothing to base their model on. They have refraction fucking them up, and they have perspective, and they will deny until their dying breath that perspective alters the world that we see, that it doesn't match Euclidean. All right.
Because they know already, right? Like you said.
I would
They know
think
certain-
so.
Or no, I mean, like, they're already committed to their beliefs. They're not going to change because, you know, they see that we're just going to show them and tell them what they already have heard. They just choose to believe. Like, they're just in this religion.
Yeah, exactly. Well, it's just so frustrating talking to them sometimes, because it's like they're not taking the conversation seriously. And that's fine. If they want to be trolls and shit, that's okay. But just so much obfuscation and evasion on every single little fucking thing. It gets so frustrating sometimes. I got to remind myself that I'm talking to people who are so set in their beliefs that there's no way they're ever going to concede. So anyway, that's what I was doing over the last couple of days. I also came across some interesting videos that I thought we would take a look at. I've got here, let me see if you guys have any requests on which ones we watch. I've got this video of this dumbass globe troll who's basically admitting to his trollery. That's what his channel's all about. That's kind of interesting.
What I done narrow it very down much, does it?
What's that?
You said I got some globe troll, and I was like, well, that doesn't narrow it down very much, does it?
No, it sure the hell doesn't. I've got some globe skeptic or flat Earth skeptic drama. So some inner drama between Arctic Reflection and this other glober who made a video about Arctic Reflection and Simon Dan being dumbasses because they got Ranty's video wrong. So this is like 5 layers deep, 5 video responses deep on this Ranty wind farm thing. It's really freaking funny. So I think I'll play that eventually. But then I got Ryan Dawson dissing Flat Earth too. You guys know who Ryan Dawson is?
Isn't he that brother of the other Dawson guy? Aren't there 2 Dawsons?
He might
That have
be.
2 channels?
I don't think so. Like Dawson's Creek or
No. I thought that there was like last year, there was a younger brother who had this really popular YouTube page, and they were he and his older brother were into conspiracies, and his older brother comes onto his show and brings up the flat Earth, and they have a discussion about it. And I thought their last name was Dawson, but I could be wrong. Hey, if you're gonna present something, can you make sure to do it here on Discord too?
Yeah.
I'd prefer it be on Discord. Thanks.
Yeah, thanks for the reminder. Okay. So you guys got any preferences on which one I play first? No, I'll just pick then.
Yeah, just go.
Let's go with the well, actually I'm going to wait on the Ryan Dawson thing because I really would like Pete to be here for that, because that's going to really get him going. So we'll see if Pete shows up. Let's take a look at this skeptic drama since it has something to do with the channel, and I'll share in just a minute. Okay. Let me undo.
In case you didn't know,
All right.
drama channels
be
are the
hearing it.
one gets all the subs and views. Not many cares about science. Maybe I just miss all the commotions, but this one was, well, not possible to miss. Let's introduce our actors first. Or should I say fighters? Standing on our left,
There's no
out
volume
of
on
my
it.
country, United Kingdom, is Ranty, the flat earther.
You
He
guys aren't
likes to
getting any volume?
understand how optics affect our
Not on
view
my
of
end.
reality,
No,
and
nothing.
how these effects can be misrepresented as Earth's curvature. On our right,
Oh yeah, you guys won't
out
be
of
able
Norway,
to
we have
because of the way I'm
Arctic
set up.
from Arctic Reflection. He is a photographer
Shit.
and
I'm just gonna go watch
filmmaker
it on
for
YouTube,
over
man. I'll be
30
back.
years. Works for a large newspaper, TV companies, and also a part-time commander of a military vessel. Now, this is not a dig at either of them, especially coming from someone like me with a tiny channel. Ranty has 5.28k sub and Arctic Reflection has 854. So what makes this a drama worthy of attention? I mean, normally you would need a popular YouTuber to be a part of it, right? Well, yes, exactly. Enter Simon Dan. I like Dan, especially his explanation style, and watch all his videos. I tried to reach out to Dan couple of times, but I guess my mail got lost in all the mails he gets. On one of Dan's video, he used Arctic Reflections debunking and ended the segment with,
Fail for him, win for us.
you can see where the story is going, right?
However, in the interest of honesty, it appears that on that occasion, Arctic Reflections was actually incorrect.
Now, I'll be brutally honest. All of us debunkers, we pounce like a hunter, and we want to be the first one to do so. Failing that, we then try to bring our own take. Look at all my videos. In this quest, we debunkers can just as easily make mistakes like the one we are trying to debunk. In essence, we become the very thing we sought out to destroy.
I think that's a pretty interesting point that he made when he says that essentially they are so quick to try to debunk flat earthers and they all jump at it at the same time that they make mistakes often. You don't hear that admitted too often by globe trolls, but I thought that was pretty interesting. And you guys can kind of catch on to what's going on here. So this goes back to the observation that Ranty looked at, that we thought maybe it was France in the background behind the windmill farm, maybe from a couple weeks ago. So the back and forth with Simon Dan and Arctic Reflections and Ranty, and now this guy's jumped in the middle, and he's a glober, and he is essentially trashing them for getting it wrong. So pretty interesting stuff. I'll keep playing.
I understand that these are my peers, but at the same time, debunking is a fight for truth, regardless which side of the aisle the opposition might belong to. A very popular video tries to debunk Eric Dubé's claim about landmarks that should not be visible. Very noble thought. The problem is, he starts with a faulty assumption that leads to a wrong formula. With that, he proceeds to apparently debunk the claims and in the process gets every single one wrong himself. Yes, I have left a comment on that video. No response so far. On every single...
What was that guy's name? This kid that's on screen here. Do you guys remember? I haven't seen any of his videos for a long time, but he was popular for a minute. But I'm really digging this. This is Glober on Glober violence here. I think this is fantastic.
My video, I'm wary of this fact. Every formula I check and recheck, and I'm still worried that I might have missed something. Maybe I'm not that bright. I believe that we can all make mistakes. Let me get my bias out of the way.
What's that, Jeremy?
It's Plainer Walk.
Is that Plainer Walk? That young guy?
Yeah, that's him.
Oh, okay. I thought he went by another name before, like a first name Shane or something like that.
He does go by another name. I can't remember.
Yeah. Okay.
I do not know Arctic Reflection personally, and at the same time, I'm not a fan of this YouTube character. It's only fair if I explain why. I have been a professional photographer earlier in my life. In fact, I have a portfolio video on my channel. I have studied photography from composition to understanding exposure. I'm talking about the film roll and pre-digital dates. It was an expensive hobby. Each negative for a photo itself was about the same price as a burger. If you actually print, it would cost 2 more burgers. This is what I know from experience. When we take a picture, we're thinking of a bunch of things, from rule of thirds to if we need to break the rule of thirds in this case. At the same time, a complete amateur can take the most beautiful photograph ever without any of those thoughts. And finally, art is subjective. I'm not talking about obvious mistakes like shaking, bad focus, bad exposure, and such. In my humble opinion, Arctic Reflection comes across as someone with a very high opinion of himself. On one video, he comments on how he can tell if a photo is good. That was the first time that rubbed me the wrong way. Later, he also talks about how P900 is a consumer camera and cannot be used for scientific purposes. Yes, it is a high-end consumer camera from my budget, and I'm not comparing it with Hasselblad, but saying it cannot be used for this demonstration is utter nonsense. Also, I disagree on being able to say if a photo is good. And Arctic Reflection does harp on how much he knows about photography. Then came a video titled, The Reply to Ranty, Was I Wrong? This was cringy for me to watch. It took Arctic Reflection a droning 5.5 minutes before actually saying he had made a mistake, followed by, So did Ranty.
So Ranty.
Huh. Oh, so he's got a lot of problems with Arctic Reflection. Yeah, I'll show you afterwards, but in the comment section, these two are just going at it. He's making some good points, really. I won't play this whole thing, but we can get this through this part where he's talking about Ranty, but he's got some good points, good criticism.
I have no problem admitting that I'm wrong. The things that went wrong with this debunk was several things. The poor quality of the video, that I didn't have all the facts, and Ranty didn't have all the facts.
What the? Now, I understand that it is possible that my comments so far, and the ones I'm about to make, might put all my work under scrutiny. But what the hell? I'm okay with that. Arctic Reflection, this is a message for you. I know I'm being picky, where most flat earthers would never admit a mistake. But as a peer, I expect more from us. I expect us to start with, yes, I made a mistake, and then proceed.
All right, so he's going to get into a little discussion about how he thinks that Glober should act and how Arctic Reflection didn't act right. But I thought that was pretty cool. So you got a Glober coming to the defense of Ranty. I think that's pretty honest of him as a fellow Glober to put some criticism out there. And his name is Dear Frog Prince. He's only got 53 subscribers. Pretty good quality video. And, I didn't mind it for a Globe video. Mostly because it was trashing other Globers. But I'm going to go ahead and subscribe to him. And I'll put a link in the chat just so people can check that out if they want to. Give him a little airtime since we played the video. Any thoughts on that?
Yeah, just basically echoing what I was saying yesterday. If you're going to debunk the flat Earth, debunk it proper, at least. Don't just start recruiting more flat earthers by doing a half job pretending that you've done something when you didn't.
Yeah, well said. And then refusing to admit your mistake when they're pointed out, especially if it's a flat earther pointing out that you made a mistake.
Exactly that.
And you know,
It's
I think
like
what he says
tactics.
about people not admitting that they make mistake, I think is a legitimate criticism, because we all have, you know, can let pride get in the way of things, and we do make
So,
mistakes.
No one's superhuman.
No, exactly. But
Apart
there's
from superhuman Rumpus.
well, Rumpus is never
Sorry.
wrong. We all know that, but
Yeah, so he thinks he's made that comfort blanket little delusion of reality that he's in. I'm never wrong. Here's my teddy.
That's funny. All right, let me go on to this Ryan Dawson videos. Pete's not here, but that's okay.
No, but he did sound. You know what I mean? He did sound. Yeah, I want to approach this from a neutral point of view, but yeah, he could be doing it just because he's got beef with Arctic Reflection.
Yeah, maybe. I don't know what the history is between these guys. But down here, you will see that they got into a little bit of a sharing of paragraphs back and forth. And Arctic Reflections is not happy with Deer Frog Prince.
Oh, well, soon be Christmas.
Yeah, so we got some Glober on Glober drama over here. That's pretty funny.
Real quick, does anybody know how much bulge you would have if you're 2 miles on the globe Earth?
32 inches.
No, that's the drop. I need to know the bulge.
Well, you're gonna have, yeah, but if you're on a ball, you're arcing in every direction, so there would be 32 total inches. You would have 16 inches on each end. That would be your total drop.
But if you drew a line through the Earth from one side to the other, how deep would the Earth be in the middle of the line? I think it's 16, isn't it?
I think it is too.
And I might want to double
Whatever,
check.
I'm going with 16.
I don't do those calculations
You're gonna
all
have
the
a
time.
hump in the middle.
Yeah.
I know 1 mile or 2 miles is.
Well, 1 mile would be 8 inches.
No, 1 mile it's less than 4 because it's exponential.
Well, that'd be your total inches. 8 inches per mile squared.
Right. So 1 mile, you've got 8 inches of drop, right? If you drew a straight.
I'm sorry.
No, that's okay. If you drew
gotta
a
go 8 inches
tangent
per mile.
if you drew a tangent out and you went to the end of 1 mile off the tangent, then that would be 8 inches down, right?
That would be a slope. So that's why you got to square it. You got to go 1 times 1 times 8. That's 8 inches. So if you say, well, what is it over 2 miles? You go 2 times 2 times 8. Then you get 32 inches, and then you just divide it in half, and that would be where your arc would be on each side of however between 2 miles. At one end of the 2 miles, you're going to have 16 inches, and at the other end is going to be 16. And then you're going to have your bulge in the middle.
All right. Can you see my screen?
No, pretend you do it on the surface. Pretend you pulled your fishing line straight on the surface. There would be that's the hump we're trying to measure in the middle. So you can't do the number from. We're not looking for the drop.
Yeah, exactly.
It's called the sagitta.
Yeah, 8 inches.
So
I think 2 miles is 8 inches.
Can you guys see my the screen? I've got the curvature or a diagram up that describes how it would work.
What's it say for 2 miles?
Right. So you would have that would be 16 inches on each of those ends right there, which would be 32 inches.
So it's measured. Let me think here.
Because if you just say 8 inches per mile, well, that means you're living on a slope. You're just going 8 inches as you go down. But since it's supposed to be a ball, that's you're gonna have arc in every direction. So you gotta go 8 inches per mile squared.
No, I get that, but that's the drop. We're trying to see what he's talking about is stringing a fishing line from one point to the other. How much it should be under the water in the middle if you're right on top of the water.
If you're standing on an apex, there will be 8 inches to the left, 8 inches to the right. So you're 8 inches above both sides.
Yeah, right.
2 miles gives you an 8-inch. 2 miles gives you 8 inches. You're saying?
Yes.
That would be
in the middle. In the middle would be 8 inches up.
Thank you.
Okay. Thanks, Clem. We'll go with that for now. We probably need to bring that up and refresh it. I haven't really looked at the curvature stuff for a while.
Sorry, I didn't want to derail anything. Go ahead. I'm writing this up.
Well, I did forget what I was talking about. Oh, Ryan.
My bad, bro.
That's all right. Ryan Dawson. That's all right. All right. So Ryan Dawson is this like prolific 9/11. I don't know what you'd call him, researcher. And he's like, I'm surprised that he's even on YouTube. He was kicked off for a long time, and that whole story. But he's been researching this stuff for like over 10 years. This isn't about 9/11, by the way. This is about flat Earth because he's going to give his opinion here on flat Earth. So this is 5 minutes long. I'm going to play this whole thing, and you guys can hear what Ryan Dawson thinks of it. So this guy's a conspiracy theorist. He's not a, he's not an establishment guy at all, supposedly. Here we go.
Next question is actually from Crystal. She is already unmuted because she's a mod. So
I had a question about like flat Earth, since I was just really curious if you've ever researched it.
Yeah, I'm friends with Eddie Bravo, who's one of the flat Earth celebrities.
Oh.
And yeah, he's. I love Eddie. We just had a talk I did about JFK got yanked off YouTube for hate speech. So it wasn't. They said we were advocating violence. We didn't. It had been up since like 2015 or something. Been up like 5 or 6 years, and suddenly it got erased. But Eddie, in the course of knowing him, became a flat earther. One of his black belts at his 10th Planet Gym came to him with this. And I think what happens is people who get red pilled too fast, they start learning, oh, you mean that was a lie? And this was a lie? And this was a lie? And then they just start doubting everything they don't see with their own eyes, right? And it's a kind of weird stage of paranoia where they're like, I don't even know if the earth is round, right? This is something that happens to some people. The earth is round. But I feel like you should be able to explain that, not just say, well, everyone says it is or whatever. You should be able to know that with an understanding, not just faith. You should be able to know on your own, and you don't need trigonometry or anything complicated to prove to yourself the earth is round. But I gave the example yesterday. I live in Japan. It's daylight here. It's probably nighttime on the East Coast right now, yet you can't see the sun at night because it's on the other side of the earth. If the sun was just doing a little donut above a frisbee, it should be the brightest star in the sky because it's so bright it lights up the other half of the earth. So it can't be bright enough to light up half the planet and yet not even be seen, yet you can see all the other stars that are further away and smaller, right? So you're either going to have it flip on the other side of the frisbee, but if you do that, then the line should move, and it doesn't. All right, I'm like, okay, well, if you're saying, where is it? Is the frisbee cut off somewhere in the middle of the Pacific Ocean or something, or what? Then how come somebody in China can't see it when somebody in Brazil can, and so on? And so obviously there's so many things, everything else in the solar system is around. You can measure shadows, you can do all this, but I feel like with flat earthers, no one wants to take the patience to answer all their little ad hoc things about gyroscopes and this and that, because they're like, you're an idiot, and they don't want to explain it to them, which I understand. I think we need to, as long as they're not being dogmatic about it. These are people with genuine questions, a lot of people had throughout history, where it intuitively seems flat. driving or walking around. It doesn't seem to be round. It's so big. But I'm telling you, there's no motive to lie about it. Like, no one gains anything by saying, aha, it's round, fooled you. You know, like, there's nothing, there's no point in that. And all the math and all the observations conclude that it's round. There's nothing showing it to be flat. But it's like, the objections I get to that, I get all these whatabouts, you know, ships on the horizon, things like, what if you look at it in a telescope? They don't know what refracting is. Like, the level of scientific ignorance is so vast that it's like, even as an adult, you got to teach them years worth of science they should have learned in school, all in one conversation, and it's exhausting. And just most people don't feel like it, don't have the energy to do it, because it's like, why? You're going to have another excuse and another excuse. But their bridge principles don't even tie together. Like, the flat earther explanation for one thing, and will have a different explanation for something else. Yet those two things can't simultaneously be at the same time. But they don't think like that. They just got an excuse. Oh, the sun is smaller and closer than what they're saying. And the earth is moving upward. Some of them don't believe in gravity either, right? It's just, to me, kind of a waste of time. I feel like other people should be talking to flat earthers. I don't want to waste my day on it, but I've thrown in my 2 cents, and I've done some videos explaining the most basic ways you can know the earth is round without really having to know math, like why you can't see the sun at night and things like that, to try and help these people from really sabotaging themselves. Because if you post online that the earth is flat, forget about getting a job. Like, if your employer sees that, you're done. And so I would really caution you about it. And you should also not have confirmation bias. Go and see why people think the earth is round, and see the rebuttals to flat earth.
Okay, so there was so much bullshit packed into that 5.5 minutes. But essentially, Ryan Dawson is like a day one glober who doesn't understand the flat earth arguments and is just bringing to the table ships disappear from the bottom up and that kind of bullshit. What do you guys think?
I think it was ironic, let's say, to hear him say, and let's not deal with dogma, and let's not deal with confirmation bias. And that's all he did.
I mean, the vets are still talking about ships over the horizon. So, like, the day one Glober and the vets, like, there's not really much more, you know. I get that all the time. Look at the ship over the horizon. Where'd the bottom of it go? You know, it's still to this day from the pros, the professional Globers. So,
Yeah, that's a good point. True. But it's so disappointing to hear this guy say this stuff that is just like, oh man, he thinks he has it all locked down. And it's just clear he has no idea what the arguments are. A pancake or what do you call it? A frisbee? And when does the sun go to the other side of the frisbee in the middle of the ocean? I mean, what the hell are you talking about, dude? Do you know anybody who thinks that the earth is shaped like a frisbee and that the sun goes underneath it?
the new Globers are a little off the hook. We had a guy in the arena the other night trying to argue that, if Earth is a 2D shape because it's flat, it's just ridiculous with some of the new people. But yeah.
Well, I think
it's.
Oh, go ahead, Glenn.
Go on. I was going to say, I think it's more they've got to clutch on to the most ridiculous parts of it, in as much as the flat Earth society going upwards and all that, and there must be a hole in the middle of the ocean or something where the sun goes, or make up some complete fantasy to attach that to the bit of truth. Let's say, yeah, it looks flat, but it can't be. The sun can't disappear. I mean, there's no way you can get a candle and sort of like walk over to the other side of a field in the dark and lose sight of that candle.
Well, let's face it, I'm not up on all of these martial arts and stuff, but my understanding is Eddie Bravo's like a grandmaster who has done special things within that art. And this little punk on the radio or YouTube is saying, well, he's obviously paranoid and needs help and won't get a job because, he's flat earther and all this. Oh, you won't get no job, warning, fear mongering. What is this little puke?
Yeah, aren't you familiar with him, Jimbo? Because you've done a lot of research into 9/11, aren't you?
Not this little guy. Nope.
Dude, this guy's big in that community. I mean, he is renowned in a lot of circles.
Yeah, I don't. What's his name?
Ryan Dawson.
If he narrated a bunch of YouTube videos or something, I might have heard his voice or etc.
That's him right there.
As a character.
He's got 78,000 subscribers on YouTube, and he has his own
back.
website.
It shows you the level of research he does. He's talking about they think the Earth is moving upwards at 9.8 meters per second squared. It shows you the level of research that this guy does. He went to the first page on YouTube or whatever, which is Flat Earth Society, and that's it. He's never even considered. So he's obviously never even heard the alternative explanations that make sense.
Yep. He's obviously, if he's done anything at all looking into flat Earth, it's at a superficial, Bill Nye the Science Guy with his boats going over that table curve. That's about where he's at.
Yeah,
Truly,
right.
Beginner step, baby steps, training wheels on.
I got an interesting bit of information for him. Right now, the sun is up about 25 degrees, and it's right now it's 6:11, and it's not as bright outside. Go figure. The sun is still up in the sky. It's over the trees, but it's just not as bright outside. And then in another hour, it'll be about 10 degrees above the horizon. You still see it clear as day. Now I can look at it with my eyes because it's not even, and still yet less bright outside. And then it just gets less bright. It doesn't go from darkness to daylight to darkness in an instant, the way the globe describes it, where it
like
just gets blocked.
All of a sudden,
Right,
dark.
It starts getting dimmer for the length of the day. I mean, it gets brighter in the morning until the sun's overhead, and it's hardest to look at the sun then. And as it starts going away, it starts getting dimmer, and the light fades out. It doesn't just go from daylight to bam. It's around the curve, and now it's dark. I mean, all it takes is a little bit of thought. You scratch the surface of all these arguments, and you find problems. So he hasn't scratched the surface.
Yep. I have one problem I'd like to ask him about. I'm looking west, watching the sunset. The sun goes down below the horizon. The gentleman in Manchester says, I can see the sun. He's 180 degrees behind me to the east. I'm seeing the sun disappear to the west, and he's telling me the sun is coming up behind me.
Well, the globe model treats the sun as if it's like all powerful and sunlight goes infinite distance. But you can falsify that on Earth. If you go into the ocean and swim down, the furthest that you're going to see sunlight is 1,000 meters deep. Now, why is that? It's because of the density of the water molecules is my contention, right? So why couldn't the same thing happen in the atmosphere over the Earth or over a distance? Who says sunlight, if the Earth is flat and everything is local, who says that sunlight continues infinitely and that it's all powerful?
Well, think of it too. When we stop seeing it, okay, it gets dark, but angle of rays. Now, when you turn on a flashlight and you look at it from the side, you don't see the rays. You don't see nothing.
So what do you think, Jimbo?
The forward moving stuff, it's still dark, even though there's, quote, a light beam in front of you.
You think that there's a shape to the sun, maybe, that it casts its light in a particular direction?
Effect. Well, an angular, if certain waves are passing at a certain angle, say horizontally above our heads, we may not be able to see them.
Yeah.
They may still be there, but they just may not be visible.
Well, that's an interesting thought, yeah.
Well, it's like, people think the sun is round. Well, If you take your cell phone and make the screen white, hold it close to the wall, the light on the wall is going to be rectangular. Pull it back a few inches to a foot, it turns into a circle. So just because we're seeing a round shape and it's lit, it doesn't even mean it's round.
That it's spherical, or that it's, or are you saying it might not even be a circle?
Circular, that's right.
Circular, okay.
We generate light from tiny little things. I have a flashlight with a little Cree in it, a little LED, light emitting diode. And I can light up a building a mile away with it.
Jimbo's right, because I got these square lamps out here down the road, and you look at them through like the camera and whatnot, and off of the distance, yeah, they look like perfect round lights when they're actually like they're rhombus, whatever you want to call it, but they're far from round, but they look round in the camera and in your vision once they hit a certain distance.
Yeah, so it's possible. But back to this Ryan Dawson guy. This kind of brings into question any of the research he's done on 9/11 for me, because if he only scratches the surface this deep on flat Earth, I mean, maybe it's not important to him, but then he shouldn't be out there talking publicly. How can I trust his other research that he's done into other matters? And I thought his 9/11 research was pretty good, but
why would you trust? You'd validate what his research was, but you wouldn't just trust it after seeing it. It's the same thing with flat Earth. A flat earther can make a claim, but don't trust it.
But why would I even listen to this guy? I guess that's what I meant.
I never did.
Well, he probably, if he would have got a disinformation site on 9/11 when he first went to research, he might have not even been into that. But he's obviously more passionate. See, people in flat Earth, even on Globe, who's passionate about the debate itself, have done more research, and he's probably done a lot of research on 9/11 because he's more passionate about it. That'd be my guess. But he sounds like a fool to me. That's the first time I've ever heard him.
I reckon that he's heavily invested, obviously, in 9/11, and if you come from if you attach flat Earth to it, you then become a crazy loon. He could lose his money, his subscriber base. So he's just distancing himself, I think. And
yeah,
you're right,
I think
he's given the generic stuff. He hasn't given an in-depth look.
I think the most telltale was all the fear at the end. Oh, if anyone knows you're flat earther, forget your job, forget, it's like committing suicide.
My boss knows that I get involved in this. But I'll tell you this, my CEO, there's a partnership and is a partner CEO, but he doesn't believe the moon landings. I spoke to him for hours, and he's a proper conspiracy theorist. He's literally, nope, don't believe him straight away. I was like, okay, we're gonna get on.
That's opening. That opens the door right there. Oh, you don't believe in the moon landing? Now where are we gonna? Yeah, it's great.
Yeah, there's more of us out there than you would think. People, he has a point that it can put you at risk to openly talk about any conspiracy, and especially flat Earth, because it seems to be the most stigmatized. Besides, a couple other ones I won't name, but
they would fire pilots for talking about these sprites. They're just electrical phenomena that come from lightning and reach upward and stuff. Many of them, they wouldn't even talk about them because they knew other pilots were fired for talking about them.
Yeah, no, I've seen that too. Yeah, and there was a flat Earth pilot that got grounded a few years ago. I can't remember her name, but she used to come in here every once in a while, and she's a pilot. And
I think she was from what's that? Not Belgium, Denmark, or right near it, Amsterdam, where the dams are. She was from one of those countries. She got fired. Well, not fired, grounded. Had to see psychiatrists, other stuff.
Yeah,
she was interviewed a few times at least, and appeared on a lot of shows, and wasn't really happy about the thing, and contended and fought it, and well, she was basically ratted out by one of her co-pilots and stuff on a flight. Suggested she might not be all there because she thought the world was flat, maybe.
And so if I was a pilot, I'd keep my mouth shut too. But we all know for a fact that there's flat Earth pilots out there. Why wouldn't there be? The pilots that are globers will tell you themselves that flying on the globe is just like flying over a flat stationary plane. You don't have to make major adjustments for curvature or earth spin. So what's the fucking difference?
I'd have to imagine that there's tons of closet flat earthers, if you will. You know, you'd be ridiculed. You might lose your job. You know, this could have devastating effects. So, I mean, I'm guessing a lot of people are just, you know, not telling anyone, not talking about it, keeping it to themselves, and just, you know, looking into it. We know Google's against flat Earth, so any metrics they show us about how many people are searching or researching flat Earth, you know, we know those numbers might not be accurate.
You check flight training manuals, and there's, after, you know, preparing for takeoff, taxiing on the runway, other stuff, you have a whole section on, quote, straight and level flying, with no mention of flying around a curved Earth. But there's a whole chapter just for straight and level flying. It's not easy. No matter what you're in, a Cessna, a small light aircraft, it's work to fly them. And they fly, ideally, you get to a certain altitude and you fly straight and level, ideally. So, well, as close to straight and level, you actually go a little down, a little up, a little down, a little up, like you're doing a sine wave.
Interesting. All right. Well, maybe I can Oh, go ahead, Jimbo. Thought you're done.
Well, it's the sort of the nature of the airplane and the wind over the wings. It's sort of like doesn't always have a constant flow, and it has to catch up. So with, you know, engine speed, resistance, other stuff, the plane sort of skips along, does a little sinus bouncy wave there as it goes along, up and down, a cycle, but it's still straight and level.
All right. As for Ryan Dawson, so I'm going to reach out to him and see if maybe we can set something up for him to come on and talk to us about, you know, his, what he said here about the flat Earth. And maybe we can have a good discussion with him and try to get him to see from our perspective why we're so interested in flat Earth, that we're not complete idiots who didn't have science in, you know, grade school.
Well, the way I see it, it never hurts to try. The invitation is a great idea, and can only hope that, you know, he would accept and come graciously.
Yeah, one other thing, he was talking about seeing stars. He said the sun would be the biggest star, and we can't see it when it's on the other side. Like, dude, you know, just on first thought, Polaris, you can't see it past the equator, if even at the equator. I guess it depends, but you know, so what the hell makes him think? And that's not from it going dim. That's from it dropping down toward the horizon and dimming out, right? And it's a combination of things. So what makes him think? So yeah, he's not even putting thought into it. Besides the research, he's not putting common sense into it.
Yep.
What do you go to the Flat Earth Society and get all his flat Earth data from there? That's great.
Yeah, I don't know. He's acting like he you know, he's done a thorough look into this, and well, I spent a lot of time with some flat earthers, but I'm not going anymore because it's kind of a waste of my time. Like he's some, you know, big debunker, a part of some community somewhere. So I'd be interested in hearing where he's hanging out and who he's hearing this stuff from. So I'll send him a note, an email, and see if I could get him to come on and kind of talk to us.
Yeah, didn't you say he said the Earth was going up at whatever meters per second squared or whatever?
9.8 meters.
9.8. That's what I meant. 9.8.
Oh, gravity. That was another thing he said. He said that gravity, we think gravity doesn't exist, which is a complete, you know, misunderstanding of most of our position. We say gravity doesn't exist. That makes it sound like we don't think things fall down to the earth.
Well, the slinky drop certainly shows that there's nothing pulling down.
Yeah. Well, we could debate about that for a long time, but he just misunderstands, you know, basically our positions as I see them. And we all have different positions. I'm just saying it's not a very nuanced critique that he put out there.
Well, yeah, that's right, because he's known about, quote, flat Earth for quite a while. Eddie Bravo, he said he was around when he made his discovery of flat Earth and stuff. That's a good long time. He's never made an effort to look into it more than superficially.
Do you think his mates rumpus?
No, I don't think so.
That would put anyone on.
No, I mean, he said he's friends with Eddie Bravo. You know who Eddie Bravo is, don't you, Glenn? Oh, did I cut out or did you guys cut out?
No, I think you're clear.
Okay.
Well, you would like to think that if he was really friends with Eddie Bravo, that Eddie would step up and talk some sense into this guy and call him out on his inadequate research. You know, if he really was.
Put him to sleep.
Yeah, because you got this big conspiracy theorist out there saying that the worst things that Globers say about us. That'd be nice. Yeah, I'm sure Eddie has had some words with him or will. Let's move on to the next video. So that's one kind of, Glober that we run into, let's say. Here is another kind. And let's see if you know anybody that's like this.
My critically thinking 9-year-old whilst watching Return to the Moon. Do they really expect me to believe they got there and then back in that cheap thing? I could build that in my bedroom. Wow, your child is so woke, I'm sure that's a real conversation. Haha, that little truther knows what he's talking about. I was 10 before my parents started indoctrinating me. For me, it was breathing. I used to do it all the time before I tried to go a full day without it. Now I'm clean and sober for 10 years. Wake up, people! So for this video, it took me like a week and a half to actually get into a Flat Earth Facebook page, like a legit one, just because my Karen account from last time, the other episode, it got shut down. Like, Facebook disabled my Karen account right after I made the video. So Karen's dead. RIP Karen. It was fun while it lasted. I didn't want to have to make a new profile, so I just used my actual profile. I managed to finally get into a page after like 5 times. So the page that I got into is called Flat Earth Academy. It's one of the top Flat Earth groups, but not like the biggest, which really sucks, but they wouldn't let me in. I had to answer all these like questions to get in. Like for this one, it says, why do you want to join? And I said, I believe in Flat Earth. I just need some evidence to send to my Glober friends. Here we go.
You, Brandon.
The average speed of a bullet,
No,
1,700 miles per hour. The speed of a satellite, 17,000. How on earth do you think you see a satellite in your backyard when you can't even see a bullet shots next to you? I was gonna post this.
All right, so I don't really think it's necessary to play this whole thing, but I wanted to show this because just as a reminder that we have these people out there in Discord, in YouTube, in wherever, Facebook, wherever it is, that are just out there to absolutely 100% waste our time. And this is a fantastic example like that. This guy's name is Sriracha, and his video is titled Infiltrating a Flat Earth Facebook Page. So he's obviously trying to go into flat earth places and act like he's a flat earther and say stupid shit. Now, you guys probably aren't familiar with this guy, but I'm sure you know somebody like him.
No, I've witnessed someone do it in Ali's, I think it was, or it may have even been Ranty's, and I've jumped into his his live chat and started saying, what you doing, what you up to, because he was blatantly talking to his audience saying, watch this, I'm going to go into this flat earthers thing, and I'm just sat there reporting it all back to Ali or to Ranty, whoever it was. It's crazy how they've got so much interest as if it's a giggle.
Yeah, and you know, it just makes me wonder, this is how you spend your time? I mean, there's some just straight up trolls. There's great good Globers out there that you can have a discussion with, but there's some straight up trolls out there who spend all day, every day, and never have a productive conversation. They're just talking shit. They're saying something stupid. They're denying any points. They're obfuscating. It's just like talking to someone who's completely unreasonable. Oh. Anyway. Anybody else got anything on that? You guys all hung over from last night?
Travis Darkus.
That's funny. Yeah, so that's that.
Yeah, Pete wasn't.
Oh, go ahead, Jeremy.
No, I was going to say Pete was running circles around these guys last night in here on the after show.
Oh my gosh, everybody was an agent. Turn your camera on. You're an agent. You're an agent. Yeah, it was really something. He was complaining that he didn't get enough mic time. I don't think that's a fair criticism, personally.
Not at all.
He might be biased when he's making that.
Yeah.
You just don't understand. That's what it is.
You don't understand. Yes, I need to put a sound clip together for You Don't Understand. I just got to figure out how to get 100 people to say that at the same time. All right, let me, I do have another video actually that this is probably more constructive. And this is from Volcano Image.
Welcome back, everybody. This is a call to action in regards to an experiment I would like to do. This is directed to anyone who lives or works at 30 degrees south or farther south than that, and must be from these locations: Chile and New South Wales, Australia, and I'll tell you why in a second. This experiment will need to be done in the month of June due to it being winter in the southern hemisphere. The observer in Chile will need to be ready by 0530. The observer in New South Wales, Australia will need to be ready by 1930 on the same day. Here is the equipment that you will be needing: a camera where you can adjust the exposure and the shutter speed. This is very important. You will also need a steady tripod and a remote control. If you have photography experience, that is a plus, as this will be very, very easy. The objective is to have two observers who will aim their cameras simultaneously toward the south on a clear June night and record circular star trails, Sigma Octantis, and the positions of the Magellanic Clouds, which are dwarf satellite galaxies. If both observers, one in New South Wales, Australia, and in Chile, record circular star trails, Sigma Octantis, and the Magellanic Cloud positions from both locations simultaneously, then the Earth is a rotating globe planet. End of story.
I'm going to play that last statement one more time.
Then the Earth is a rotating globe planet.
I didn't go back far enough.
If both observers, one in New South Wales, Australia, and in Chile, record circular star trails, Sigma Octantis, and the Magellanic Cloud positions from both locations simultaneously, then the Earth is a rotating globe planet. End of story.
All right, so he says, if both observers record circular trails, Sigma Octantis, and the MC positions from both locations simultaneously, then the Earth is a rotating globe planet. End of story. Is that a true statement?
It's true if you use the model of the sky they use and you know exactly how the sky works, what everything is, all the distances and everything. You know, you have to know exactly how the sky works, then maybe yes. When you stop presupposing how the sky works, though, you don't know.
Yeah. I see we joined by Aaron Armstrong. Hey, Aaron.
Hey, man. How are you?
Good. How are you doing?
I just have a couple of minutes before I drive my daughter to school. I just wanted to make a comment. You're just talking. I was listening to you on YouTube, so I don't know what the delay is, whether it was a minute or just 30 seconds or 5 minutes. But you were talking generally about Globers, coming on and ridiculing and making no sense and a whole bunch of other stuff. And
Not all
they waste
Globers.
all
We
their
were talking
time.
about certain ones, Aaron. Not all of them. I did say some Globers are good guys too. But go ahead.
Yeah, I heard you say that. I acknowledge that, recognize that. But you have to remember that there's a bunch of really crazy flat earthers as well. So when you generalize or when you make comments, you have to understand that there are people like Pete. There are people like, those guys that drink their piss, or like Jimbo who thinks there's a 3,000 long seahorse. I mean, these are the people that you're dealing with in your own team. So if you expect people not to ridicule you, then it doesn't make a lot of sense to a lot of ballers,
No, it's not ridicule. It's the wasting time and spending 12 to 16 hours a day talking about absolutely fucking nothing constructive. That's
I know,
that's
but
what
you
I have a
guys do that
problem with.
as well. You do it as well. Not you particularly, but flat earthers do it.
No, I'm sure. Yeah. I'm not saying that flat earthers are perfect and ballers are all shit, dude. I'm just talking
Well, that's the way it comes
specifically
across.
today. No, dude. No, I know
Maybe
that
I'm
there's
just
some flat earthers
maybe I'm biased. Maybe I'm
I agree with you. There's some
maybe I'm
crazy flat
biased.
earthers, dude.
Anyway, have a really nice day, guys. It's a beautiful day in Australia. What is it? Almost 8:30, 9 o'clock in the morning. Getting to summer, beautiful skies, absolute cracker. So enjoy your day, everyone. See you later.
Cool. Thanks for popping in. He takes a shot at you, Jimbo, and doesn't even give you a chance to respond. What the hell?
Brandon, I sent you a DM if you can turn that into something coherent that can be displayed for people at some point. Not right now, but
Oh, okay. All right.
my whiteboard work is not that great.
Gotcha. So this has to do with the experiment.
Yeah, the line, yeah. I'd call it a measurement. Otherwise, you're going to start getting a lot of fucking criticism. But
Okay. All right. I see we've got Space Pope that's joined us. What's up, Babs? You there?
Yeah,
Not
mic
bad.
check. Can you hear me?
Yeah, you're a little low, but not too bad.
Yeah, I'm just listening right now.
Okay, cool. All right, so back to the star trails thing. So one thing that gets me about the star trails is when they say if both observers record circular star trails from both locations simultaneously, would that prove a globe? This guy is saying that it would prove a globe, period. And I have a lot of questions about what he means by seeing both at the same time. Is he talking about the exact same time of day? I don't know if he said that. Or is he talking about
nothing you're gonna see is gonna prove it definitively. I said this in the first 3 minutes of the show. Nothing optical is gonna end it. I don't care what you see. If you see a unicorn on the horizon, whatever, nothing optical will be definitive at this point.
No, I agree with you there, but I'm trying to figure out what this guy is asserting here because I see a lot of ballers pass this around too. I think B-Ball is always posting this one. That if you see these at the same time, and I think Professor Phil has put this forward too. So what if you see them at the same time? How does that prove that the Earth's a globe?
To them, it does because they think they know how the sky works. This is just for them. They have this model of the sky and how it works and everything, and so to them, this is some ultimate proof right here. But if you come from a different position and you don't speculate on how the sky works, then it's not definitive what they're saying with the star trails.
So if the Earth were flat, I mean, there's many other possibilities why you would see the same thing, but let's just say it's at the same exact time. Greenwich time. So it's like 3:30 in the morning, and they both look south. Are they both looking dead south? Or is one looking southeast and the other's looking southwest?
That's the question, and they
Right.
are slightly
Yeah.
off. They
Yeah.
they will never ever be both looking dead south. What you'll get
Right.
one dead south, let's say, but the other will have to look slightly off.
Yeah. Okay.
I've checked this out. It's all born in a meme that was probably about 6 years old now. There was a big set of them done, and this was one where what they actually said to start with is if you draw an AE map and you put someone in Australia, Chile, and South Africa, and you point the line all outwards to the ice wall, and they were saying on a globe you can see octans in all three locations at the same time. Little do they know that one of them has to be in daylight, so that's impossible. But I went and checked it. I spent hours going right the way through it, and you can never ever get two places looking directly south perfect. There will always be one slightly to the east or slightly to the west.
Really? Okay. Is there you got a diagram or anything you could show us? I'm having a trouble picturing why they would.
Well, if you if you just search Google and put flat Earth octans, and I bet you it comes up straight away, and go to images.
Okay.
And you'll see, yeah, they just point it out in all three directions.
Flat Earth octans, OCTANS.
Yes, exactly.
All right.
And by the way, in England we call it Greenwich Mean Time. It's not Greenwich.
I wasn't going to correct him.
Does it have two E's or does it have one E?
No, that's the way how you say it is perfectly how it's spelt. So Greenwich is how it's spelt, but
Well, just think
stupid
about.
English.
I just wanted to get that
English people
straight.
go
I just wanted to
Greenwich.
get that straight, Gleam. That it does have
Yeah,
two
but no,
E's in
it
it.
is us English. It's an English stupidness.
Hmm.
It's
Matter
Greenwich.
has two T's.
There's a town
and
next
listen,
to me.
listen. If you're a beatnik in New York and you're going to go to Greenwich Village, if you say, "Where's Greenwich Village?" They're not going to tell you.
There's a city next to me that's called actually called Greenwich.
Well, sure, but that's the white boy pronunciation. That's like down here in Maryland. Here in Maryland, there's a town that is spelled Bowie, but it's not Bowie. It's Bowie. You know.
Try
Anyway.
Beaufort and Beaufort. Same spelling, two pronunciations. There are places called Beaufort
Yeah, but
and others Beaufort.
Travis, why don't they spell it Bouy then? If it's
hold on, what happens
That's
if
all
you
about
flip the W?
pronunciation and yeah.
What if you flip the W?
dyslexia.
Travis,
What?
what happens if what happens if you flip the W though?
Yeah.
All right. So this octant thing, what are we looking at here?
Yeah,
Gleam?
well, it's similar to this. This is an updated version where they've obviously had to go into it because it was destroyed to start with. That was way back when Nathan Thompson's group was about 10,000. Put it that way. But yeah, it's similar to that. On that right-hand picture there where it says cross, there will never be an instance where you'll see the same star at the same time in relative time, in as much as you will see it in their own time zone at their own time. So if you see Sydney, let's say that's 2 o'clock. Jakarta, that's 2:45.
Okay, so if this one's looking
Johannesburg,
this
you'll see it
way
at 5
and this
a.m.
one's looking this way at the same exact time, Greenwich Mean Time, 2
Yeah, they
a.m.
never see it directly south, both at the same time. One, we'll put it this way: if it was directly south of Jakarta, Sydney would have to look slightly. Is that east? Sorry, west. So southwest, they would have to look.
Even
so they would see it.
Even
If-
Sigma
if it-
Octantis?
Yeah, let's say Sigma Octantis is right in the center of the cross. Yeah, Jakarta would have to look southeast. Sydney would have to look southwest. None of them would see it directly
what
south.
is Gleam? What does magnetic declination have to do with that? Because how do they know where south is?
Well, that's where the grid is. Yeah, it's exactly that. But the coordinate system is already laid out in as much as you know which direction you're looking in Australia to go south. Or how
Well,
they
wouldn't you
plan
use
it.
a compass or something, some sort of magnetic
Yeah,
device?
yeah, or GPS. That's programmable ones.
Yeah.
But yeah, but put it this way, it works on a flat Earth because it's like a clock. If you imagine that X there, that travels around. So every single place will see the same stars, but in their own time zone. Let's say it's 1 a.m. it would be in Sydney, and then 1 a.m. in Jakarta time, local time, it would be in Jakarta, and so on and so on in their own local time zones. They will never ever see them because obviously half of it's lit up by the sun anyway. So maximum 3 of these would be in darkness.
Yeah, it's never midnight in Cape Town and Buenos in Argentina or whatever, right?
Yeah, that's it, exactly that.
I mean,
So-
at the same time. So when they talk about, oh, you're looking south, we see this southern point or whatever. They fail to mention that it's dusk in one place and probably dawn in the other, right? Just coming up on dawn and just
That's
going
it.
into dusk, you know.
Well, there's no mentions of times here at all.
Yeah.
At what times you'll see them.
Yeah, they just make us try to assume that it's midnight in both places and we're looking both directly south, and that's why we see it, and that's why it's round.
Well, that's the part that's never been clarified for me, and that's why I think it's a lame claim, is because all they do is say you'll see the same stars, but they don't add any of that other information in there. Like this is really lame claim.
So
what about the shot where it's from the equator, where you can see both polar rotations?
yeah, I wanted to get into that real quick with Gleam or any of y'all. So let's say I'm at the equator. We're at the equator in Ecuador, right? And I point my camera north, okay? And Polaris is supposed to be at 0 degrees, right? Just barely above the horizon. Is that kind of the claim?
The claim is you can see 1.5 degree past the equator headed south. You can still see the north.
So I dip my camera down through a small bulge of the Earth, apparently, to see Polaris from ground
I think
level.
I think it would be
chucking it up.
I think it would be pertinent to elevation. I think a lot of these places at the equator have higher elevation. That's why you can get.
Data, your mic's really muffled
in the camera.
Sorry,
So then-
sorry.
then
Hold
I
on,
take
hold
that
on.
same-
Data, flat Earth Data. Your mic's really muffled. Sorry to interrupt. Go ahead.
I could understand it, but yeah, it was a little muffled. So I take that same camera. It's on a rotating tripod, just like an auto level, and I turn it to the south, and allegedly I can see 1.5 degrees lower. Wait. Isn't my camera on a level rotating base? So if I'm pointing down a little bit to get Polaris into my center of frame, and I just rotate that camera, wouldn't it be going up 1.5 degrees ish, right? Or would I have to adjust it back down to then see the southern point, they call it? Do you kind of follow me there, Brandon?
Yeah.
Yeah, so I've got my camera on a Lazy Susan, and it's level. And in order to put Polaris in my center frame looking north, I may, like Flutter FED said, I may have to tip the camera down a bit to get Polaris. Now, if I rotate that, if I level my camera back out, rotate that around, I'd have to tip it again to see the southern point. Now, here's the issue I have. Let's say I point my camera straight up and I put it on that time lapse. You've seen the time lapse of both the Polaris and the southern rotation. Seen that with that wide angle lens they have, apparently.
Yeah.
Goes
Yep.
190 degrees.
Kind of like that picture we looked at yesterday. Yeah.
Yeah. I'm having a hard time understanding how, if I'm on a level Lazy Susan, right? My camera's level. I just point it straight up to 90. How can I see both at the same time? How is that possible?
Well, on the globe model, 180 degrees is directly, let's say the celestial pole runs through it. 0 would be the celestial pole. 180 would be the south celestial pole. According to them, you can see the stars everywhere in between that. That's 180, no matter where you're standing, even on the equator. So you would be able to see Polaris theoretically at 0 and Sigma Octantis at, whatever it is.
And so let's say I have my camera straight up from the equator, and I can allegedly see a point to the north and a point to the south, and I put it on time lapse for 15 minutes or whatever, or 1 hour, so 15 degrees. How am I going to get a circle around the 2 points there? How am I going to get the lower arc around the bottom of the celestial point, and an arc of a star around the lower of the north point? Shouldn't I only see what I would call above?
Yeah. No, I agree with you. On a globe, you're talking about, you shouldn't see the full circle. You should only see maybe like half an arc. I don't know. I think so.
Something hokey with all those pictures.
Well, what it's doing is it's highlighting the bottom from the middle, right? It's almost like you can see the bottom of both both these.
Yeah.
If it was a globe, you're seeing both the bottom and the top of the globe from the middle, and that doesn't make sense because it's like laid out at 180 degrees, like you said.
Pretty much tangent. You could even call that a tangent line, which why would a tangent wouldn't point to Polaris? Like you said, you'd have to go down a certain amount of degrees at both, observations, north or south.
Well, here's the thing. In all honesty, I have never done the personal observation myself, so I'm going off of what I can research for data, and a lot of the information that I see, like Gleam pointed out earlier, is they don't discuss time zones, so it's a misnomer. These southern direction views, because they're not, anyway, it's just a red herring, I should say, because it's not actually focusing on what we're talking about. It's because each individual observer sees their own stars. So that means it's traveling to them at their location at that time, right? To them, because that's what it is. It's on a cycle, right? So.
Well, their model doesn't take perspective into account. So they get these, they say you see a 180 field of degree, field of view. You see all around you in 180 degrees because they're so far away that even though you've got that horizon 3 miles away, it's such a distance away that it's coming, you're seeing it above your horizon.
Oh, all right.
Yeah.
So at my same point there, let's say I was in Ecuador at night and I saw that this bullshit we're talking about, kind of the circulars around each north and southern point. Take me halfway around the globe and just pretend it's night on the whole globe. So if I were to go to the exact opposite point on the equator, 180 degrees around, I'd allegedly see the same thing. And how is that possible if I'm seeing those 2 points above the horizon when I'm in Ecuador? And if it was night, on the whole globe, and I went 180 degrees from there, and I looked out tangent, 0 degrees, whatever it is, I shouldn't see that, right? You follow me there too?
You shouldn't see the stars that are in the sun. Is that what you're talking about?
No, pretend it's nighttime around the whole globe. There is no sun, so we're just doing a star observation.
No, but if you're doing a star observation of the North Pole, the sun, at least in the summertime, would be on the other side of the globe, and you're still seeing this. I guess that doesn't matter though, because you're in the darkness looking out.
Hypothetically, I want to say there is no sun, and I just want to put you 180 degrees from me across the globe. So put both on the equator, and say, so I see that strange picture they show us of half circle rotations below Sigma and below Polaris. And then if you would never be able to catch that same thing. If I'm able to see Polaris and Sigma above my horizon, because they're so far away, right?
Yeah, but once again, are you adding in your elevation? Because elevation, if you're higher up, you're going to see farther away. So
let's
if
just
you're
keep
going,
it ground level.
Yeah, but Ecuador is 1,500 feet above sea level, right?
Ecuador is bordered by the Atlantic and Pacific. So let's just say I'm
Yeah, but
on
it's
the beach.
1,500. It's 1,500 feet. So if you're 1,500 feet above the ground, you're going to see farther, right, than if you were at 6 feet on the ground.
Well, I think
So
I'd see
you're gonna
farther over the on the Earth, but I don't know if I'd see farther into space. Would I?
no, you'd see farther over the plane, right? The higher you go. So if you're taking these camera observations, your elevation is definitely important, because the higher the elevation, the more the camera is going to see farther out. That's just the way it is. So these particular observations are 1,500 feet above sea level. So that means the observer is going to see more terrain, right? He's not 6 feet on the ground. He's 1,500 feet in the air.
Brandon,
Right?
can you bring up that video that I've just PM'd? Sorry.
Yeah.
So I take it with higher elevations in these camera photography, still or time lapse footages. Elevation does matter, I believe, and how you can, what you can get. If you're closer to the ground, you're probably not going to get these bigger white circles, right? But if you're higher in the,
is Polaris 90 degrees above the North Pole? Apparently,
I haven't seen any evidence of it. I haven't seen any photography of it.
in their world, right? In their
well, it's according to the globe, but the problem is that according to their globe, they're not sitting on it's an imaginary pole, but they're off by degrees, right? So they're actually not they're not end pole to pole.
On the model, the simple model.
Well, just if you go to astronomy now, Polaris is off and a Sigma Octantis is off, and they're off by like one degree or so. So if you were to have a pole from point to end to end, and they're off by a degree, well, they're not lying on a pole, so it's not technically a 180, right? Not technically going to be a tangent from pole to pole. They're off by a degree, and that's huge. A degree is huge.
That's what I'm getting at too. Yes. So if I were at a reasonable elevation, let's say 30 meters or something, on the equator somewhere, and I looked out tangent north and south, that's as far as I can dip my angle, because the horizon is only 3 miles away, right? Or maybe 4 or 5 at that elevation, but I can't look less than tangent. Right? I can't look down through the bulge to see something behind the bulge, which would be Polaris, or even if it's 1 degree off, which is supposedly 90 degrees straight up from the pole. And I'm 90 degrees straight out from the pole, looking tangent towards that 90, And, they make it make sense by saying, oh, it's so far away. That's why, but still, the angles involved, like you're saying, would come into play. You would not see the bottom rotation of the stars on their time lapse under Polaris, unless you're at a super high elevation. Maybe.
Yeah, I don't know, because they've got it worked out to where they're so far away that your angle to them, even a little bit off the ground, it does work out, because I've looked at it before. But you should take a closer look at it, Aaron, in some kind of model or something. I mean, the idea that they're fucking trillions of miles away and light years away is ridiculous anyway, but they've got it worked out somewhat, at least.
Yeah. With distance, yeah.
Yeah, with
Brandon,
distance.
that video, if you go to 50 seconds, it's a 360 degree, and it's pointing at the North Star to start with, or the North rotation. But I just want you to slowly rotate it so you've got to click on it, and then if you move your mouse to the right, so it will go to the left.
You want me to rotate it?
Yeah, literally click on the screen. It's a 360.
Oh yeah, okay.
Yeah, and if you press play, and then just as you press play from that 50 seconds mark onwards, you'll see what I was trying to explain yesterday, where that is the center of rotation. And when you look to the southern part, when you're on the equator, so if you press play, because it's actually a time lapse.
No, it is playing. I turned the music off.
Sorry.
Oh no problem.
Yeah, no, there's stars supposed to be moving. Yeah.
Oh, they're moving on my screen.
Yeah. Sorry, I'm watching on the live screen because I can't see you on Discord for some reason. You're still on the other video.
Discord. It's not playing on Discord.
Oh, you guys can't see me on there?
But no, it's not streamed live. But just before it ends on this bit, if you just scroll to the left, click on the actual YouTube video, and grab it, hold your left mouse button down, and move to the right.
All right, let's try it again. Now I am sharing in Discord again.
Yeah, now it's good.
So where do you want me to go?
Yeah. So once you press play,
Yep.
is it playing?
Yep.
Yep. Go to the left-hand side. So you have to push the mouse to the right.
So, okay, go to the left. All right.
Yeah, and then you'll see where it starts splitting up into be the equator, and then it goes into the southern stars.
I hope Brian's paying attention.
If you see, they're all going the same direction. Yeah. If you keep on going,
Yeah.
going.
Yeah.
Yeah, until you get over to the other horizon where it's arching across. Now stop there. So it looks like a rainbow, yeah?
Yeah.
And we know that this is how the sun crosses our sky. Pause that up on that bit. Yeah. That's how our sun crosses our sky. But from a globe earther's point of view, that is actually a straight line because it's obviously the Earth moving and circling around. So in the same way with perspective, it comes in off the horizon. It's kind of like a bell. So it comes in off the horizon, which is very small, angular size from the horizon. And then when it's above your head, obviously it's big in the arch or arc. So that I'd say, you remember when I was saying, if you imagine a record player right above you and you're just a little ant and you've got a massive 12-inch record above you, each of these grooves are still of the record. It's just your perspective is bending them around the southern hemisphere that way, but that's on the edge of the record going that way.
Right, they're above you. So when they're on the outside, the closest
and they just
spot to
keep
you,
going.
if it's a record, is the space in front of you. So this would be closest, and you'll see that's when it goes up. And as the record goes around, that spot gets further away from you, and because of perspectives, looks like it shrinks down. So it goes in an arc.
Yeah. And the further away it gets, the more arcier it gets, and that's why it rotates around that, or appears to when you're down there.
Yeah, so this part makes sense to me. Now, when you see
Now, I've
actually
tried
Sigma
that.
Tempus, where it's
Gleam.
like actually going around like that, that's the part that I can't quite wrap my head around. I don't know how it works. I don't think it proves a globe, but I don't know exactly how it works. All right.
I tried to model this. I tried to model this in Blender with that particular concept. The only way I could get it to work is if it's literally through a dome, like literally, like you've seen the demonstrations on YouTube.
Yeah, no, I've seen
couldn't.
your video on it. I think I see you do it. You created the dome over your head, didn't you?
Well, that's for the personal observer. See, there's a combination here. I think there's two effects that are hard to model. One of them, obviously, perspective is something that occurs here, but the way that the rotation would be affected through, let's say, liquid or whatever you want to say, glass or whatever you want to say, to emulate the effect. I could get the opposite rotation through the. You've seen this before. People have done these videos where they've taken a desktop glass dome thing and they put it over the circle, and you can see these rotations. Like they put circles in them, right? So it's a combination of those two effects. I think that it's hard to emulate in these Blender programs. I can't get it to work as a disk up top. I've been trying to figure it out. The only thing I can do is use those added assumptions.
Well, there's
to get
a
it
problem
to get it to
too,
work.
is that Blender is a Cyclops. You can use stereoscopic modes with it and get through 3D, but normally it's just like a camera lens you're looking through, or blinking and looking through one eye. You don't get the 3D depth and other effects. And as far as these star rotations go, for me, just in short, the way I see them is sort of like when you see crepuscular rays, and then you can see them reversing the other way across the horizon, like anti-crepuscular rays with the crepuscular rays. This it's almost like a mirror reflection of one side on the other. And I think the northern side is the original light source, and the so-called southern hemisphere lights in rotation are the weaker of the two, or the reflection, in so much as the Canis, the dog star there, is invisible. They call it a -2 whatever. You can't have negative light, invisible, black, dark, and call it a star. You can't see the Canis Octantis or whatever.
Now, the only way I was going to say,
That's between others.
the only way that I got that I got a version of it is to actually add in the personal. It's like you add in a personal dome, and then you add in the refraction outside. So you're adding your vision plus the well, it's basically you're adding in your perspective with that personal dome aspect, but then you're adding an extra layer of the atmosphere above, which is also, you're looking through atmosphere that way as well. So it's like a combination. It's hard to do in Blender. So I can't. I'm gonna still kind of work on it to get it through. But Blender is limited. I can't get it to emulate reality that much anyway.
That's it. You need something like Unity.
Even put your stars farther away, and there's a way. How do I put it? Of adjusting the camera's focal length to way beyond.
I've done that. I've done that. There's actually quite a bit. There's some quite interesting anomalies if I go to a 20 mil to an 85 mil, and Blender has this interpretation.
You've got to set up the camera. Yeah, I know all
Yeah.
about it. It's pretty difficult. But Brandon, can you load up that video?
Yeah. What? Real quick though, Brandon, before you leave this one, what's up with the color of these stars? Right, these trails.
It's just light. It's obviously long exposure.
Not just that. Some of
To
these
have some nice
people-
blues and whites and violets in there.
The people who do star trails for
forgetting
sites
clouds.
and lots of promotion, they often enhance it. I saw one guy doing his star trails and stuff, breaking them into, I guess it was Photoshop, and just adding all this and adding contrast and brightening up this and that, and embellishing it.
Yeah, these aren't natural videos, right, Jimbo?
They're obviously blue shifting.
You can make. Did you see the tutorials on how to make star trails in Blender? It's quite interesting how they do it.
Yeah, and the fact they set them 5 miles up. Blender stars are set at 5 miles of elevation.
Before we move away from,
real light.
oh, go ahead, Jimbo. Sorry.
I just was saying that it tries to emulate what the eye sees in anything in life, from texture to depth to you name it, including how light is absorbed under the skin. It's called subsurface scattering. A portion of light that hits your skin gets absorbed by the skin and dispersed in it. Only a portion reflects off, and people see when they look at you. Stuff like that.
No,
Very, very accurate.
Blender is only as accurate as it was programmed. But I will say about this video, it's pretty freaking cool. I'll put the link in the chat. And Gleam, you said you had another video.
Yeah, I've just sent it in the inbox. That's even better because this shows you how to do it, how to resolve exactly what we've just been talking about for 5 minutes.
Okay. Well, let's play this and see. Do we need sound?
5 minutes and 10 seconds. If you want to, he won't strike you. He's a flat earther. But 5 minutes and 10 seconds you need to go from. If you give
turn the sound on.
Would look if we removed the atmosphere. The place is Canary Island, Spain. The lens that I used here has a 122-degree field
I haven't
of
heard your
view,
Blender sound
and as
all
you can see, the stars
whole
never set because they are too
show.
high for perspective to make them rise or set. Their altitude now is about 4,000 miles.
Blender, like anything,
This number is
do on
fairly
audio,
accurate and matches the rise and set times shown in the programs such as Stellarium. Now I am going to play the same video, but with the atmosphere or atmosphere added. As you can see, the video has changed completely, and the star trails look exactly like the original picture. Here is the original, taken on March 15th, 2015. Now let's play the two videos side by side so you can see the effect of the atmosphere. We can do this from any location. They all work the same.
And what program did he use here?
Hold on.
Or,
Hold on,
3D
hold on,
Max.
guys.
3D Max, okay.
Or, okay.
Yeah, I remember watching this video where they said they added in actually
Hold on,
the
guys.
data, they placed everything.
Hold on. You guys are going out. Look, let's let the video finish, then just tell me when to stop it, Gleam.
And here is another test in France. Look at it carefully and compare it with the original, and let us know if we're doing anything wrong.
You got the basic concept there.
Okay, that was pretty interesting. So maybe just walk us through what he was talking about, what was happening there.
Yeah, literally what he's done is he's created that record player. If you see back at the 5 minute and 10 mark, if you just flick that back and just pause it there.
5:10. Okay.
Just a bit after that, where he's showing the stars.
There you go.
Yeah, there. So if you see, it's like a record player, as I was saying, with all the grooves. And then there's a tick button, a tick box basically in 3D Max, which is add standard atmosphere, which is your 7/6R. But it just adds it to that, and literally ticking that, then matched up or made his model where he's put all the stars at 4,000 miles up, roughly in line with the sun. The sun in his model has to hover between 3,800 to 4,200, but he put all the stars just at 4,000, and they started matching up as soon as he to real world star trails from Tenerife. This one is. And that's where you obviously see both axis of rotation similar to that time lapse that we just saw a minute ago.
So in the beginning, he has it no atmosphere.
Yep. So that doesn't touch the horizon, basically, is his point.
And then when he changes it
And
to add
yep.
the atmosphere,
Yeah, it all bends up and wonkies out and looks
that looks
as if it is.
pretty dang close. Let's look at this side over here. There we go. Whoa. Pretty dang close. I don't know. What do you think, Data? He must have stepped away. Well, that's cool, Gleam.
Yeah, but the channel, Steve Torrance, people would know him. He's been on the scene for a long time. Is with Dr. Zach. Dr. Zach is also narrating this very video here.
What was
He's
his
now-
video about I'll just call it the egg thing? That was a great video.
There is the one I'm thinking that you're thinking is he does the magnetic field one, which is more of
the
a
one
disc.
where he had this. Well, it was like a three layer dome shaped thing. It looked like an egg, so I'm calling it the egg. It wasn't what he called it, but
Yeah, no, there is one that looks like an egg, which is 115 years of all the planetary movements.
Dude, it
and
was
that
a
looks like an egg.
great video. Yeah, yeah.
He did one too with the angles of the sun and stuff for light on objects.
Yeah. Well,
Really
the
good
good
one.
thing I like about Steve is that he models a lot of the globe as well. So he'll actually have his flat Earth model and his globe Earth model and put them side by side, which is like kryptonite for the globes. They're like, no, we cannot test it to a flat Earth model. It might work.
Exactly.
What the heck? Ranty's not subscribed to him. What's going on, Ranty?
Sort your head out.
There we go. That's taken care of.
He's actually part of FE Core, so he's one of the boards.
You know, I haven't watched too many of his videos. I gotta check this out. He's got quite a bit on these. What's that site called?
Yeah, the Earth Null School.
Yeah, right.
Yeah.
Steve Torrance is the African American British fellow, right? Or am I wrong? Or am I thinking about a different
Wrong.
Steve?
He
Oh,
looks a bit like me. He's a bit of a hippie.
okay.
Plays the flute.
Wrong dude. Wrong Steve Torrance. My bad.
Yeah, but what he does as well is he's done a whole line. If you go into his playlist, he's done a whole line of sun measurements. So he's literally timed the sun to move its own diameter. And he's done multiple, there it is, sun measurements. And he'll literally just exactly that. He'll just, no solar filter. It's just to say, look, this is the size of the sun based on that. How long is it going to take to move from its own diameter?
Interesting.
So he's started to actually put more videos out, and I don't know whether, hopefully, that's due to a rise in interest. But yeah, he's done a lot, and as I say, he's not scared to say, well, the globe Earth model can actually represent it. The flat Earth model struggles, but he's also got more there that says no, the globe Earth model completely fails to do it, whereas the flat Earth model does actually look like it. Done all the balloon at high altitudes and stuff like that.
Can you post that, Brandon, or have you? And
I did in
maybe
YouTube.
general?
Yeah.
How about general?
Okay.
Yeah. I'm gonna go sub
Yeah.
to him.
That magnetic one's really good. If you click on that one just as a last one, it looks weird, but it's kind of like how the field of magnetic ether would work, let's say.
Which one's that?
It's a big yellow disc if you scroll down a little bit.
Okay.
It does it in a couple of languages.
Let's go with English. I didn't realize he was part of FE Core.
Yeah, he's a board member. Yeah.
Any particular part of this? Should I skip forward or?
Yeah, just skip through. I think it is just that animation. There. Yeah, anywhere there.
All right, what is this supposed to be, Glenn?
So this is the electromagnetic field, let's say, over the flat Earth.
Ah, okay. Interesting. Cool. Let's see what it does.
So it's funny how Torrance equals 33, eh? Same with Rick Hummer equals 33. Kavanaugh, Mike Kavanaugh equals 33. It's funny how they're all last names equal 33, eh?
Yeah, but aren't there a lot of last names that equal 33?
What are the odds all the members on FE Core all equal 33?
Every single one of them?
You guys are in there.
Mike Kavanaugh does. Don't get excited, gentlemen. Don't get excited. Don't get excited. Every time I bring it up, look at you guys get excited. So Torrance equals, listen guys, Torrance equals 33. Kavanaugh equals 33.
In which one?
Hummer equals 30. Don't get excited, bud. They all equal 33.
Which one?
He's just asking which one, Data. That's all.
Go fact check it in general. Just go look at whether it's Pythagorean, Chaldean. Just go look at it. The point is, what are the odds that of all the members that they all have 33 associated? Even if you take Bob Nodell's full name, 22 plus 11 is 33. Even if you take Karen B in her full name, it's 22 plus 11 equals 33.
Because we're all agents.
Real quick.
Yeah. So guess what?
Real quick, if you're into numbers, I just posted something in general. Pretty big coincidence with a lot of stuff we do in here.
Yeah, exactly.
Okay, I know what you brought up. Yeah, I'll bring that up in a little while after we get done looking at this. So the 33 thing is interesting, but you know, I don't know what the odds are. What are the odds, Data?
Well, I went to other board members of other companies, and here's the funny thing: some board members have 22 and 11 in their names, like Apple's board. Or you look at Samsung board, type in their names. Just go look at the boards. The odds are that all the members from FE Core all have 33. I found that very interesting.
Flat Earth data equals 33. I mean,
Flat Earth equals 33. Not Flat Earth data, but Flat Earth equals 33.
Yeah. No, because I did the data with my gematria, and it comes out to 0. So you only take the 33.
So Flat Earth equals 33.
Yeah, and you have that in your name, so.
Sure. The point is it's not my full name.
I'm just joking with you, FED. I don't care.
Now you're suspect. You are a suspect.
Yeah. Don't
We
let
all are
Pete.
suspects.
We're summoning Pete right now. Come on, calm down.
No, it's just funny how everybody gets excited when I bring it up because I do find it.
Nobody got excited. You got a little bit excited.
I had no idea flat Earth itself equaled 33. I had no idea.
It all depends how you add it up.
All right, so back to this. So they're showing what the magnetic field would look like over a flat Earth, and then it looks like he's.
Yeah, that was it. There was an animation bit beforehand, but yeah, it's essentially that.
What is this? Is that Is that the sun streaking over like a time lapse?
I don't honestly know.
Oh well, maybe I should play it and find out, huh?
Unless it's Russia really attacking, and this is news.
And it can be verified by tracking the speed of the sun on its azimuth and declination.
Yeah, it's the sun. And there's a picture of that. That's pretty interesting. Cool. All right, so this looks pretty cool. Lots of good stuff in here. I'm going to have to spend some time checking out his videos for sure. He's working with Dr. Zach. Zach does good stuff.
Decimal Z is known as.
Oh,
yeah,
Decimal Z.
is pretty awesome, but he has one issue.
33.
He's trying to solve it. Is that basically something to do with sun angles? I can't remember the main argument, but he did the seminar, and he was talking about one of the problems. Do you remember what it was?
Yeah, Polaris and the sun angles.
Yeah, it was that. Okay. Just wanted to double check.
Yeah, that was in the first video. They did kind of resolve them with that same atmosphere. He took 300 data points, didn't he? And
That's what he said. Yeah, that's what he said.
Yeah. Well, it shows the Excel document with all the angles recorded in there.
Whoa.
And that's where he built on, and then he says he had to get a lens, didn't he? He'd done the lens thing, but he was totally out of scale anyway, and he knew that because he was using nails, wasn't he? Nails on a table.
This is the same thing that CrowXE uses as his thing, the analemma. Same picture of the analemma, or same diagram. You know what? Maybe somebody here can answer that, FED or Gleam. I have a question about the analemma. Now, no matter where you are on the Earth, it's always going to look like on the northern side has the smaller circuit, and the bigger circuit is on the southern side. If you're in Australia, you're going to see the bigger side closer to you. If you're in England, you're going to see the smaller side closer to you. Correct?
It's the tilt on their model, isn't it?
Right, the tilt. Now, why would the tilt create it so that it's symmetrical? Meaning, why does it look the same no matter which hemisphere you're in, no matter what time of the year it is? The small part's always towards the north, the big part's always towards the south. You would think as the sun went around, it would even out.
As the Earth orbited, yeah.
Yeah, as the Earth orbited the sun, but maybe I'll have to look into it more. I'm sure they've got an explanation, but that's just in my head what I would think.
Yeah. It's not equal.
Yeah, it's not equal. Does anybody know the explanation for that?
Kind of explains the South Pole or ish area there below 60 being much colder. Or actually, it's a what do you call that? The opposite, right? So they're saying that the sun there, the analemma, is bigger in the south. It's always smaller in the north. But yet the South Pole is the coldest place on Earth, right? But it has more sun time, maybe, right?
Well, if on a flat Earth, no, I don't think it has more sun time. On a flat Earth model with Polaris in the center and the sun revolving around Polaris, it would cover more ground. It would go further.
Oh yeah, this distance between yes shots, exactly.
Per 24 hours, it would have to go much further than it went inside the equator.
Making that southern big or
Have
that
you
Analema
lined
part
up
bigger.
the sun Analema to the equation of time? Have you compared the path of the sun Analema to the equation of time?
No, I haven't. I haven't researched it too much. Just surface level, really. Why?
Yeah, I'm
What happens when you do that?
Well, I'm just asking if anybody's done it, because the equation of time is based on man's constant of time, and it shows you that that there's a duration in the earlier months where the sun moves at a faster speed, and then the later months it moves at a slower speed, or vice versa. I think I got that backwards. I haven't looked at it in a while, but this I'm going to compare the sun and Analema to the equation of time, because once again you're still, observing a natural event, and then you're comparing it to a construct, right?
Yeah, good point. Yeah, you're right. And you'd have to look at how this is constructed too. Isn't it based on solar noon though?
Well, this is plotted over time, so it's a daily representation of the sun's position at a specific time. And also what it's doing and what you're seeing is an infinity loop, or if you cut it in half and put it end to end, a sine wave, like an airplane going up and down, up and down.
Infinity equals 33.
Well, yeah, but what we're seeing is basically not only the infinity symbol, it looks like, but an infinite loop.
Yeah. Well, you put the 2 3s together.
Yeah.
Infinity.
Is there any connection to that and the origin of the infinity symbol?
There may very well be. I couldn't say yay or nay with any certainty, but it is what it is. It's plotted over a year. There's probably 365 positions. So that's one a day over a full year. And to the observer, that's the path.
Yeah, I'm going to look into this some more because I'm very interested in this. So,
well, again, if you think of the observer's position and the fact our eyes make a personal dome, what you're seeing is a crossover from his personal point of view of that transitional crossover from his right side eye dome view to his left side eye dome view.
Jimbo,
I have a question. I have a question.
On the earth.
I have a question. A lot of these sun Analema pictures are taken from ground elevation. Have we seen any other high elevation? Can you find any? I can't find any high elevation.
I've never seen any done like in the mountains of Peru or anything. I've never seen any done.
That's what I mean. So I think that actually might change a bit as well, what we perceive based on our elevation.
Jimbo and FED, let's just say, let's go to the globe model, right? So at December in the northern hemisphere, we're tilted towards the sun, and at June or whatever, we're tilted away from the sun, right? On the globe model, and on the equinox, I'm tilted sideways from the sun, right? And then on the autumnal equinox, I'm tilted the other way, sideways from the sun, not towards it or away from it, just sideways, right? So these observations of the Analema, why is it a consistent infinity sign when taken from the same spot, same time, same location, all that stuff? Wouldn't my tilt be different in March and September? Or does it matter when we're looking at the sun in this respect?
Well, that's what I thought their assumption is that's how they notice the tilt is through the sun Analema, right? I think in the 1300s when they were studying the sun Analema, they weren't studying the tilt of the earth, they were studying the movement of the sun.
The Analema is tilted in every picture I see, right? The full year observation is tilted for some reason. And then they'll say 23.4 degrees, but what about when we're tilted the other way, or the dude taking the pictures is tilted the other way? Wouldn't the bottom
There's a
the
problem, and a major one, when it comes to the tilt and the seasons. Because here, when it's our winter, we're actually like supposed to be several millions of miles closer to the sun, because our orbit isn't a perfect, circle. It's supposed to be ovalated, like a oval track almost, but not that exaggerated. So at 2 points in the year, we're actually closer physically to the sun. Yet when we're closer physically here in the north, we have our winter.
Yeah.
Which is opposite logic in the
Exactly.
helio
Have you
model.
looked at the Vatican oval sundial that they have in the Vatican Church? Did you look at that and apply it to the Sunalima?
I didn't know they had one that was oval.
Go look at the Vatican. If you can bring up the Vatican right now, Brandon, just type in the Vatican Church. Look at the sundial in the center. It's the belly of the snake. The Roman Catholic Church
Is
looks
that
like a
with
snake
that
head.
obelisk in the middle?
That's right. Go look at it, and
Okay,
that's the
I
sundial.
didn't notice it was ovalated. I thought it was like opened at one end or something, but I think it might be ovalated a little bit. I'd have to look again. But yeah, those are often basically very large sundials.
That's right. So look at its oval shape there.
Here it is,
And
a top view.
There's the oval shape right there. So that's the belly of the snake. That is a sundial. Now I haven't got into it yet, but I think there's a correlation between that sundial, the Sun and Lima, and that I just haven't worked it out yet. So I'm just looking into it now.
Damn, I never noticed it was oval. It slipped right past me, and that's important. That's absolutely important.
Absolutely,
And
it's telling
went
you
right over my head.
telling you the truth right there. The belly of the snake right there.
It's also in the shape of a key, the way they present it here.
Yeah, if you look at the origin of the upside down cross entering into the mouth of the snake, or entering into the building, yeah, that's what it looks like. I think Jonathan Kleck pointed out the snake thing, but I was researching the sundials and wanted to know why this is the only sundial that I can find that's an oval shape.
Yeah, the thing about, I don't limit it exclusively to kind of the snake worship, because that was Naga. There were other lizards and snake-looking things that weren't really snakes too, I think, that were worshipped and godlike and whatever in the time, So.
Yeah, of course. Yeah, it's all. If you read Morals and Dogma, they'll tell you it's just an inherited oligarchy, technocratic, pharaoh, family tradition, if you will, handed down from the Templars.
Vatican equals 32, but with the obelisk there, that's 30. That you add the 1 and boom.
Very funny. So listen, you want to mock the 33, buddy?
I don't want to go into
Get this.
it. No,
When coronavirus came out, it said coronavirus connection. Once I read the CC, I was like, oh my god, this is a psyop. And what happened? Fucking psyop.
Exactly.
CC is also
there's something to it. Yeah,
copy
there's something to
conform.
it.
What's that?
CC is also illegal here for copy conform. It means it's a copy of a legal document, and it's valid. If it's not, if you have legal documents and you need copies and they're not certified with CC copy conform, you pay for their authentication. Basically, they don't count in court or nowhere.
There's definitely something to the numbers that FE's talking about. A lot of folks talk about it. We've all heard it, because if you want to fool and rule a population of minds, just don't speak the same language, right?
Exactly.
and you're good.
I think part of the thing too is for misdirection to be at play. It's to get the certain crowd to believe they can recognize symbols and signs, but it's a misdirection.
Well, during the Second World War in Britain and other places, the Allies used crossword puzzles and designed their messages to their, directing staff and admirals and stuff in crossword puzzles.
Yeah, through the most common
in
medium, the newspaper, right?
Everyone read and solved, but they didn't know they were actually reading, top secret information right under their nose.
Exactly.
Cryptic clues.
Well, isn't it interesting that if you do get a little understanding of how they communicate, you start looking for it, and you never did before.
It's so serious too. Like the code breakers, the Navajo code breakers, all had a sort of a bodyguard. It was an escort that if they were to be captured, they weren't to be captured. Their escort was to kill them.
Yeah.
Exactly. Wasn't their friend.
It was he's a murder hand on hire, just in case the one with knowledge was about to be captured. Yeah.
Imagine a conversation. Hi, I hope you don't have to kill me.
Oh, that's a standard with Pete.
So, do you guys know of any other sundials that are oval? They all our versions are all circular, but the Vatican's is oval.
They're on a different level, dude. They're on a different level.
Well, do you think they're just, because the idea here is even Kepler, I think they don't have elliptical formulations. They have eccentricity formulations for these paths. They can't actually be accurate. They're off actually. So they have to stick with 2 pi r in their calculations. So I wonder
Imagine if we had access to the Vatican archives and all those secrets down there. Volumes, just it's huge what's down there. And it all belongs to the ruling Pope. He decides who gets to visit, who don't. It's pretty weird. All that information should be public, should be ours.
FED, Jimbo, you've heard the idea that on a flat Earth, the sun, when it goes out to what's the furthest one, Cancer, and then through the year it moves across the equator into Capricorn, and I might have those mixed up, but either way, there's the Globers say, well, the sun has to speed up, right, to keep this 15 degrees per hour, blah blah blah. Well, we've just been talking how the Earth's orbit in their model is elliptical. So from equinox to equinox, there's more distance to be traveled in the larger loop of that oval, as Jim said, or elliptic, right? And so the Earth has to speed up and then slow down and then speed up and slow down. So as we know, everything works the same on flatter globe,
Yeah, this was a question I was trying to break in with too on the same lines, if I can. On the flat Earth model where I live in the U.S., the sun would be further away from me in the wintertime, and that's why it gets colder and creates the seasons, blah blah blah. But if that sun is further away from me and is traveling at roughly the same angle in the sky, then it would have to. That's why it's not in my sky long. It's going fast. To move the same degree, it would have to be moving faster, correct? If the radius that it's traveling is larger.
Well, that's what the equation of time says. So if you look at the equation of time, it will show you. I'm just going to bring it up, and I'm just going to because I keep forgetting it. So it says in the earlier months, it's going to. Let me just see here.
When the solstice happens in the summer and the sun is right at so-called the equator and aligned or whatever, it sort of comes up the same place for 3 days and then starts moving again.
Yeah,
and Rakia, we would have to. Well, just real quick, Rakia, just upon what you said, I would have to take from horizon to horizon, right? So if I'm looking at the south to the sun or whatever from summer or a winter perspective, as you are, it's always from horizon to horizon, right? So I'm not sure the speed has to change, because if it is a little bit further away, right, perspective comes into play. It's still going from horizon to horizon, but it's a shorter distance because it's further away. It's not that I'm tilted.
That's what the equation of time alludes to, is that it shows that it's up to 10 minutes before the hour, and then as it moves through the winter months to the summer months, it actually is longer. So it's like 14 minutes after the hour and 10 minutes before the hour, based on a 66 by 24 construct, right? So if you're,
I'm just relating this on the daylight time. during my winter, the days are much, much shorter than in the summer, of course.
Yeah, so the sun, based on the equation of time, it will show you that the sun is actually moving faster in that regards, right?
Gotcha.
If you were to
But the
if you were to look at
perspective
that.
thing makes sense too. If it's further away from me, of course it's going to be below the horizon more of the time, right? In the winter because it's further away. So that makes sense also. When you combine the two, you still get that 15 degree per hour, but it's not in the sky as long, if that makes sense.
Mm-hmm.
I'm gonna get off either way. Salute to everyone. Nice one, Brandon. Have a good one.
Thanks, Liam.
Take care.
Thanks for popping in, man.
Everyone,
Yeah,
smash
cheers,
that like
Liam.
button. Where's the super chats? We need some questions.
We did get a super chat for $5 Australian, I think. Is that what A is? From Upside Downer. Upside Downer, thanks, man. Appreciate the support. I did bring up the
Cool.
equation of time. I asked George if he was willing to come on and explain the mainstream explanation for us, but maybe he doesn't want to do that. We'll see. I'm curious to hear what the globe side has to say about why it's shaped the way it is from every vantage point on the Earth, essentially. I'll have to look more into it.
If
Yeah, Rocky,
everyone,
I get what you're saying about the, yeah.
if everyone would, now that I'm, every time I'm on a panel or whatever of Globers, I'm asking them if they think that atmospheric conditions can obstruct things beyond, in the distance, like buildings, the bottom of buildings or boats or whatever. And what I'm coming up with, the ones who do answer say yes. And this is something that they've denied for years. And if the more people that can hear that, as an audience, the more they can understand how that boat or that building is being obstructed, and it has nothing to do with Earth curve. There's no mention of Earth curve when you're talking about the atmosphere obstructing something. Whether you call it a mirage or mirroring or whatever you want to call it, it's still the atmosphere making that effect happen. And almost to the T that I've asked, they're all agreeing with that.
There's so many great quips, right, Rocky, you bring out, and me and Travis had this idea probably a year ago or more. Say we need to go back through Jose's shows and because you'd get Rumpus to admit something or Sean G or all these folks to admit something. We need to compile all that, but we're busy, right? We have jobs and shit. But if we could just compile, from what you're bringing out, recently, I mean that those sound bites would just speak for themselves, So I don't have the time to do it, but if you could possibly link to us somehow, say, hey, on this show at a roughly this time, I got somebody to say that I didn't get them. They actually said this. They spoke the truth. And, somebody who has time, put it together because there are so many, Rakia, and they keep admitting more.
Yeah, I'll try and start making notes of it. I'm not really into that. You know what I'm saying? It's more about getting them to admit it to the audience, and then people can make up their own mind. But I'll start making a note because, it's not. I'm not just going after the Joe Blow. I'm talking to M. Scott Beach, Zanuck, all the big players, and they're all Jose admitted it in front of his whole show. The first question I asked him was, Jose, you've done a lot of observations. I know you know what's going on out there. Do you think it's possible that an atmospheric condition, whatever you want to say it is, can make that water appear to bulge up or whatever, make that effect happen that would block something beyond it, bottom up? And he said, yes, I do think that could happen.
Yes. Yep.
Plain as day. Got him to repeat it. They're all
Yeah, but that's
saying
being honest. That's good. At least he's being honest. That's good, man.
Yeah, but here's the dishonest part. And then they'll come back and say, "But we've never denied that." And I'm like, "Are you kidding me?" That's been my claim for a year or two now. Just like my claim was that you can't look through the crosshairs of a theodolite because on different days it's going to show different things. Well, they would never take my picture that I take of my crosshairs. So I waited to get George's crosshairs. And now every time they say, "Oh, I use a theodolite over 2 miles," I say, "Oh, really? How do you know it's accurate?" Well, it's accurate. Well, what about this? And I show them George's picture, and it's over. I mean, you can't use that, and that was my claim for over a year, and they called me ignorant for a year. Even George, right? George had
even
these
George.
pictures. Yeah, Jesse, George, Larry, all of them called me ignorant. Told the audience I didn't know what I was talking about, and I was lying. And when I post those pictures of George now, they say, "Oh well, of course it happens with refraction, right?"
Yeah.
And it's just upsetting. You know they're deceiving the audience, and that's why I'm here. I mean, this you know, like I said, right or wrong, what they're doing is not right.
There's somebody out there that does good compilations, kind of like I think Chemo's done a couple, but it's not what he focuses on. You know, folks, there are folks out there that put together certain compilations like that. Yeah, Nathan Oakley calls it his toe tag, but that he's just focused on, you know, his show. But just something like that, dude, just to get those conversations. And like you said, Rocket, they only last 3 minutes. You ask one question, right, and you get a truthful answer. And
I
man,
would
if you
just
had,
challenge everybody to ask the same question to these people that are leading these shows and get whatever answer they get.
Yeah.
That's a good idea. If you guys come across something like that, a conversation where you think, oh shit, this is really interesting. They admitted something we've trying to be getting them to admit for a long time. Yeah. If you send me a link, man, I'll cut it out.
or just jot it down, right? Well, let's keep a little notebook, right? Because I'll listen and I'll hear it, and I'm just driving my truck. I'm like, yes, right? But I don't jot down time or show.
Sure.
I should do that. We should do that.
Anything, just a quick message in Discord or whatever. But we got Gordzilla 37, $5 Canadian says, then they said, and there's a gas giant within this endless vacuum. LOL. Good show, he says. Thanks, Gordzilla 37. Appreciate it, man.
Gordzilla, you didn't know that gas attracts rock? You didn't know that?
Gas giant.
Funny how the sun is an expansive energy, but yet it has pulling properties. Everything about the sun's expansive, but then yet it holds everything together.
Yeah, but it's funny how the asteroid belt hasn't apparently formed into some sort of planet also.
Oh, that's 50 billion years from now. Didn't you know the science is out?
Yeah, it gets a little
It'll probably be next
ridiculous.
year, actually. Yeah, they'll start saying that shit.
Don't give them any ideas. All right. Well, it's 7:46, guys. Gonna call it a night. Let's do our final thoughts and get out of here. I will be back tomorrow at 5:00 Friday evening show, and I'm hoping to have some fun. So get yourself a 6-pack, and let's see if we can get something good going on Friday night. Why don't we go down the list first, alphabetical? Let's start off with Chad. You want to say anything tonight?
Good show.
Short and sweet. Thanks, Chad. Cool. Flat Earth data.
I'm going to look more into the Vatican sundial, look at the rituals that are pertaining to it, see if I can find any correlation for the equation of time in the sun and Lima. I know back when I got into Flat Earth 45 years ago, I was looking up in the 1300s the Arabic astronomers studying the sun and Lima. And they have an equation for it. They had their own theory behind it, and it had nothing to do with a spinning ball. So, but anyway, Brandon, good show. Looking forward to it.
Yeah, thanks, FED. Yeah, it'd be interesting if someone could do some more research into the Analema too. If anybody's interested in that, I'll probably do it myself, but I think there's something there possibly. Jeremy.
Yeah, we're not on a globe. Have a good night.
Oh, I got that picture you sent in Discord, and next show that you're on, I'll bring that up. We could talk more about it. Sorry I didn't get to it. I kind of forgot about it.
Yeah, we might want to whip that up into one of your nice PowerPoint presentations or something, because that's a little rough draft there.
Okay, yeah, I can throw something together. That's no problem. Cool. Jimbo, you still there, Jimbo?
Yeah, still here. I think it's still okay to try to study some of the things of the lights and the sky theater that we witness. Everything that happens up there is regular and predictable and has been for thousands of years and will be for thousands more years. But I also will never be able to measure my floor by looking up.
Yeah, good point. Good point.
That's all I got to say.
Yeah, I think it helps just to understand what they're saying about it, but that's a great point. Patient zero, Aaron.
Yeah, a lot of they people would call this an echo chamber, and I consider it exactly the opposite, right? So many different topics, so many different inputs. We don't all get along with each other. We don't all agree with each other. We can talk about it. People can chime in. You had a couple Globers give some comments in here, and no one was like, "Oh, get him out of here." It's like, okay, yeah, all right, let's think about that. So, and your final thoughts, or final thoughts on a Flat Earth show, yours, Ranty's, or whatever, kind of attests to that. Where Jimbo was just talking about something that I didn't even think about. It wasn't even kind of on my radar, and it wasn't so. There's no echo in my mind. We're not all sitting there going like Jose's final thoughts. Great show, Jose. Everything's great. Yo, man. We'll see you tomorrow. Blah blah blah. And so, cheers to the panel. And Brandon, outstanding.
Cool. Thanks, Aaron. Ricky.
Yeah, thanks for the show. Another good one. I like this format. I don't think there's any reason to let the likes of Rumpus or anyone else like that come in here and just take over the show and ruin it. This show is for everyone, right? We should all be able to speak our piece and give some input. I'll say this, like I've said from the beginning, every man, even our enemy or our opposing views in this case, has truth inside, and we can use that to make our points better, or you know fight against it. So, but every man has truth for sure, whether they know it or not, whether they're saying it. This atmospheric thing, we've known this for a long time, right? And it took over a year to really. Ranty spent basically, almost killed himself doing it. I spend a lot of hours of my time free of charge doing it. I love it. I mean, this is what I like to do, being out in nature and observing things. And I knew it in my heart it was true. Now I know for a fact, right? This is something I can be confident in. I can prove it. I can show it. Anyone can go and do it. We just need to scream it from the mountaintops. So thanks a lot.
Cool. Thanks, Rakia. Yeah, well said. And Babs, you there? You want to say something?
Yeah, Matt, aka Babs. Yeah, I tuned in kind of late, and I saw Jeremy's new experiment, the one that he's working on right now. I still feel like the straight line is probably a better idea, just because of the issues that came up before with the catenary curve. You're not going to be able to get rid of the sag out of that neutral buoyancy cable. So even I know that some of the methods that we're talking about for drawing that straight line are a lot more complicated, but considering all the errors and the things that could happen with the cable, I still think that the line is probably just the best way to go. I don't know. That's just me. Something else I wanted to ask. I had a question that I wanted to ask Gleam, but he's not here anymore. But it had to do with the star rotations. So the circumpolar stars move clockwise around Sigma on Octantis, as seen from the equator, and the two celestial poles are on the horizon due north and south, and the motion is counterclockwise around Polaris and clockwise around Sigma on Octantis. So the thing I don't understand about this is if you're observing the star rotations from the equator, wouldn't they both be moving in the same direction? I don't understand how one of them is moving clockwise and another is moving counterclockwise. I'm not saying that it's impossible. I'd just like someone to explain this to me in a way that makes sense. But yeah, that's my final thoughts. Catch you guys on the flip side.
Cool. Fair questions.
Later.
For sure.
Later, Babs. Can I just respond to Babs real
Yeah,
quick?
go ahead. Yeah.
We actually want. Is that cool, Brandon?
Yeah. Go ahead. Yeah.
We actually want the sag because the sag favors the globe. So we don't even want any kind of buoyancy in the line. We want it to sink that way, because if it doesn't sink enough, it has to sink a specific amount, or it's not bulging. The water's not bending. You know what I mean? But we'll go over it again later.
Yeah, you're gonna have to explain that to me, because I looked at the diagram that you sent me, and you're gonna have to explain what you mean by the sag is gonna have to be a specific amount for it to make sense on the globe.
All right.
I didn't get that, but yeah, we'll talk about it later, I guess.
All
Hey, and Babs, it's actually you that's moving clockwise and counterclockwise at the same time. Just so you know.
That's impossible.
All right.
You're
Guys.
You're also accelerating downwards when you're just standing still.
Yeah, that's also impossible.
All right, we'll let them continue. Maybe if we wait for them to stop, they never will. I did miss a super chat from Upside Downer. The chat frozen. I didn't see it, but thank you very much. You sent 2 super chats for $5, so I appreciate that very much. And thanks for supporting the show. Appreciate it, everybody. It was a good night. We'll see you tomorrow night, right around 5 o'clock, 5:05. Should be an interesting, given it's Friday night. So until then, talk to you later.